Please welcome to the stage Vercel founder and CEO, Guillermo Rauch.
Good morning. Good morning, everybody. Thank you, GM, and welcome back. Hello. Today, we're having the 6th annual Next.js Conf. I'm pumped to spend the day with everyone here in this room, and a special shout out to the thousands of people watching around the world, especially our watch parties in London and Berlin. Thank you for spending your time with us today. Last year, when we met, we were a year and a half into this app router era of Next.js. And at that time, our framework was being downloaded 7 million times per week. And over the course of building the app router, we made a lot of bets. We'll be talking a lot about bets today. When it first launched, it had the earliest mainstream implementation of React server components. It also supported nested layouts. It used the file system as the API for its routing features. And it kicked off the development of TurboPack to ensure that this new server-first architecture would scale to apps of all sizes. Today, Next.js is being downloaded 13 million times per week, nearly double. Thank you. Nearly double the adoption in just 1 year, especially with AI math, right? That tells us that many of our bets are paying off, and we're so grateful to the community who has helped us get the app router to where it is today. Thank you so much. But how we're writing software has changed. When we started the app router, GPT-3 had just come out, ChatGPT or Chat didn't exist, GitHub Copilot was in beta. In a very short amount of time, we've gone from writing code by hand to getting suggestions, to having models write code, to now having agents that author, test, execute, and ship entire features. And what we've seen with these LLMs is that they really push us in terms of the design of our own APIs. An LLM's context window is even shorter than a human's attention span. So if we make an API that's confusing for anyone in this room, the LLMs stand no chance. The easier we make the developer experience for humans, the better we make it for agents. So with all of this in mind, let's take a closer look at our bets and see which ones paid off and which ones were regret. A novel, unproven architecture. Fast forward to today, and we're seeing RSCs gain adoption in popular ecosystem projects like Vite, React Router, Redwood SDK, Waku, Parcel, and more. And other projects like Tanstack Start are actively working on an integration. What's more, even outside of React, projects like Svelte are bringing more and more of their rendering to the server side. The server is so back. So this is quite remarkable about development. RSCs provide an idiomatic way for all React apps to fetch data and compose server-side and client-side logic together, regardless of the framework that you choose. So we're excited to see all of these innovations continue to come to the React ecosystem and the adoption continuing to spread. Server actions are another feature that we're seeing pay off. They let you handle API requests directly inside of React. And between React server components and server actions, Next.js now has support for first-class idiomatic APIs for both data reads and writes, which is something that we never had with the Pages router, as much as I loved it. We're also seeing success with our new routing architecture. Layouts persist across navigations. This is kind of like the dream of React, right? Avoiding unnecessary renders across navs, maintaining ephemeral state during RSC updates. The router also supported advanced routing patterns with parallel and intercepting routes. And our file system conventions allow every screen's UI, data, and logic to live together. So these features have enabled a new level of scale for the most ambitious applications. Finally, one of our biggest bets has been TurboPack. I remember when I first saw a demo of TurboPack, and it was performing fast refresh in single-digit milliseconds. I was like, holy cow. But we asked ourselves in that meeting, is this worth it? Because a human under 100 milliseconds is all kind of the same, right? But for an agent loop, every millisecond counts. TurboPack now drives more than half of all Next.js 15 development sessions, with over 500,000 developers using it every week. It's astonishing. And after releasing it as a stable for development last year, our ambition for this year was to enable it by default for all new apps. So our first milestone was to ensure that all of Next.js build time features continue to work. This meant getting the existing suite of 8,266 tests to pass. It's an incredible accomplishment. But we then proved it in production. Our own internal sites adopted TurboPack for builds, giving us the confidence that it was ready for everyone. And today, I'm thrilled to share that TurboPack is the default for all apps on Next.js 16. And we're not deprecating Webpack anytime soon. We are shipping both. We care a lot about backwards compatibility, and we're setting up Next.js to be incredibly fast for the majority of our users. So, speaking of Webpack, when compared to Webpack, we've seen up to 7 times faster production builds, up to 3.2 times faster initial load times in development. And believe it or not, astonishingly, up to 70 times faster HMR updates in Next.js 16. If you take a look at these numbers, you'll see that TurboPack is especially good at updates. Once it's warmed up, it can track tasks at a granular level and avoid redoing unnecessary work. But in reality, if you stop your dev server, all that work gets kind of thrown away. And if you start a new dev session, you have to start over from scratch. So we've been iterating on this problem all year. And today, I'm excited to announce that file system caching for development is now in beta. It extends the in-memory task tracking of TurboPack to full server restarts by leveraging the file system, the good old, reliable, awesome file system. And this is going to be particularly awesome for the largest projects in the ecosystem. I have one more teaser. We're already working on bringing this amazing innovation to your production builds so you can develop and deploy faster than ever. So the investments that we've made in our new bundler are really paying off. But we live now in a world of agents that can continuously open pull requests and create preview builds. And for this world, TurboPack is going to pay off 1,000 times over. Speaking of agents, another bet we're making is on the importance of keeping models up to date with the latest best practices in Next.js. That means understanding features like server components, server actions, even features that we're announcing today. Who likes when Claude tells you, you're absolutely right, and it uses an old API, right? So to support that, we're open sourcing Next evals. Next evals is a public benchmark that tracks how well the latest models and coding agents can build with Next.js. This is an investment into the ecosystem. The better AI gets at Next.js, the better everyone's developer experience will become. So if you're in the AI space, we'd love to collaborate. But now, let's talk about the bets that haven't paid off. There's one big one that we've been iterating for the past 2 years. Any guesses? Yeah, that's right. Caching, our favorite word as computer scientists. We try to make things static by default. This is kind of the background of it. And our efforts to marry the static rendering capabilities of Next with the app router's nested layouts resulted in kind of confusing APIs and unpredictable behavior. So let's take a step back and take a look at the bets we've made with the app router. A little bit of a bet review, our portfolio. So here they are: server components, server actions, file system, TurboPack, and caching. So if we squint our eyes and focus on the ones that paid off, what do they have in common? Any guesses? It's a little bit of a tough one. Composition and collocation. Our best features really embrace these qualities, right? So you have this ability to reason locally. Server components, for instance, they let you fetch data in every component. Whereas get server-side props, our old API, it was restricted to your page module. And our caching APIs kind of went global. So fetch, cache, no store, export const, dynamic, force static. It gives me a little bit of PTSD. So these APIs introduce implicit coupling and unpredictable behavior. And nobody likes spooky action at a distance. That's kind of how those APIs behaved. So this really all comes back to React's core value prop, right? Composition. We've seen time and time again how well this principle has served React, both in the longevity of the first-party APIs, but also in how rich the ecosystem has become. And today, this idea of betting on composition and avoiding spooky action is even more important, because it's not only better for humans, it's essential for our friends, the LLMs. So let's kind of evaluate how, or think about how well LLMs can work with React code that uses Tailwind, right? Works great. That uses Chatcien. Raise your hand, Chatcien. He's not here. Or even React pages in a Next app that have both server and client logic in one file. You get to understand everything right there and then. So composition wins over separation of technology every single time. But caching spends lots of technology and lots of stacks. CDNs, in-memory stores like Redis, browser headers like cache control, CDN cache control, TTL, vary. It's been hard to figure out how to compose all of these things together, which is why caching kind of always felt like it was separate from React. It's this thing you have to worry about, rather than another Lego brick that stacks up perfectly. But RSCs, if you think about it, they brought concerns right into the component boundary. They brought server-side rendering, for example, into the component boundary. They brought API routes into the component boundary. And with use cache, we're bringing caching into the component boundary. So I'm very excited to now invite Sam up here to tell us all about the future of caching. Give it up.
Morning, everybody. My name's Sam, and I'm super excited to be telling you about everything the Next.js team has been working on today. Now, it's kind of funny that I'm up here because even though I've been plenty involved with the Next community over the years, I only just joined the team a few months ago. And one of the first things I asked my new teammates was, why does clicking around the app router feel so slow? I mean, sometimes you click a link and it's fast, usually if it's a static page. But sometimes you click a link to a dynamic page and you see zero feedback. And then eventually a new page comes in. It's almost become a meme at this point. don't get me wrong, I love the DX of the app router, and I think server components were a great addition to React. Especially for just fetching data and rendering it on a page, the DX is really hard to beat. But I just didn't understand why using RSCs meant we had to give up on the snappy client navigations that we're so used to in our React apps. I mean, isn't that one of the reasons we love React, is the ability to run code right in the browser? Why couldn't we just use RSCs for the initial page render and use good old client-side React for everything else? Now, eventually I got my answer, and to be honest, it was pretty fascinating, and that's something I want to share with you today. But first, I want to set the stage. I want us to understand the problems that the app router was actually trying to solve when it was first created in 2023. So, what did other React frameworks look like in 2023? Well, most of them looked like similar to each other because they followed the broader web ecosystem. If we go back, the earliest front-end frameworks bundled all of our code on the server, and then they sent it to the browser. And the browser was then responsible for rendering, data fetching, and routing, kind of like an iOS app. Except the web is not iOS. People want to be able to open up articles and links to tweets instantly, which is exactly why in 2012, Twitter's engineering team shared in this post that they cut their initial load times by 80% by moving a lot of their client-side rendering back to the server. They also split up their code into smaller bundles so that they could lazy load them as needed. So we started seeing features like server-side rendering and dynamic imports making their way into our frameworks, things like get initial props. But the story doesn't stop there. In 2017, Netflix shared that they had removed all client-side React from their landing page. By pushing even more rendering and data fetching to the server and letting pre-rendered HTML do the heavy lifting, they saw a 50% improvement in the performance of this page. So again, we saw the trend continue. More APIs, doing more work earlier on the server, kind of like get static props. Now, what about those snappy SPA navigations that we all love so much? So what about this routing layer here? It turns out that teams that relied exclusively on client-side code for their routing concerns also ran into performance ceilings. In 2018, the engineers at Square wrote about using a new Ember feature called Engines to break up their dashboard into sections that could be lazy loaded. And it's funny because at that time I was working on Ember 2, and I remember LinkedIn doing the exact same thing. They adopted this feature, Ember Engines, because the sheer amount of URLs on their site was causing performance problems just by loading the entire client manifest, the route manifest, into the browser. And as one more example, recently Remix added a fog of war feature to help with this exact same problem over at Shopify. So I make all these points to say that after a decade of experience building with these rich front ends and the development of the entire framework ecosystem, this was kind of the state of the art. We had these hybrid frameworks that were primarily client-first SPAs, but they kept adding server-side features that you could opt into when you inevitably hit the limitations of the client. And this brings us to RSCs and the app router. The goal of the app router is to solve these problems at a foundational level. And we knew from experience that the client-centric approach was a dead end. That's why the app router defaults to rendering, data fetching, and routing on the server with server components. We wanted to bake all of these hard-won lessons from the community directly into the framework so that you and your team never hit these performance ceilings and feel like you've outgrown Next. But here's the thing. I like snappy client navs, and I like opening my iPhone and seeing pre-rendered screens sitting there waiting for me. So shouldn't we have this option to pre-render certain screens or pre-fetch upcoming client navigations so we can provide the best user experience? I think we should, and not coincidentally, so does the rest of the team, because that's exactly what they've been working on and what I'm excited to share with you today. It's a new feature that unlocks partial pre-rendering, which we started working on about 2 years ago. And we're calling it Cache Components. It lets you pre-render and pre-fetch your UI, bringing instant navigations to the app router. So let's see what it looks like to work with Next.js when Cache Components are enabled. Now, if you're like me, you're happy it's fall because football is on. So let's make a little fan site here for college football. It's going to have real-time scores up top. It's going to have the current standings of the teams. It'll have some news stories and so on. So we're going to start with a simple layout for now. And we'll just get started by rendering the header. And this is just a static list of links. So that's looking good so far. Now let's create a module for the home page. So we'll create our page. And this is going to be the standings. So we'll add an H2 for the standings label. And then let's go ahead and add a panel. And this is coming along. And now we actually want to fetch the data for the standings. So we're going to add a fetch call here to our server component. So let's go ahead and add fetch. We'll fetch from the API, and we'll iterate over and render the teams inside of our panel. Now, when we save this and reload the page, we're actually going to see an error. It says, uncached data was accessed outside of suspense. This delays the page from rendering. And it specifically calls out our fetch call here as the culprit. So remember when we talked about slow navigations at the beginning of the talk? Well, Next is telling us here that because our new fetch calls are outside of any suspense boundary, they've made our homepage a blocking route. This means that if we were to load it, we'd have to wait for all the data before we see any content from the server. But if we go back to what we just had before we added the fetch call, we just saw everything on the page that didn't depend on those fetches at all. All this UI could have been rendered by the browser before the fetch calls even finished. In fact, before they started, the browser could have already started the work it needed to do to render this page, like fetching the static JavaScript bundles and the style sheets from the server ahead of time. So let's go back, and we're going to fix this error by unblocking our route. And what we're going to do is we're going to move the data fetching code into a new component. We'll call it the standings table. And let's go ahead and render it in our tree. And now we'll use suspense to unblock it. Suspense provides a fallback. Usually you provide your own, but for now, let's just use a null fallback. So if we save and reload the page, the error goes away, and we see our static content again. And now, once our fetch calls complete, the data streams in. Pretty cool, right? This is pretty amazing. At first glance, it might look familiar. I mean, haven't we all seen skeleton screens before? And lots of frameworks have APIs for deferring data fetching so that, our whole page isn't blocked by the slowest fetch. So how is this any different? Well, there's something special about this skeleton screen. It's static HTML. That's what that error was all about. Next is guaranteeing that this route can be pre-rendered into static HTML. And if you've worked on Next before, you know that if you can make a route static, it's usually pretty good. It usually ends up in an extremely fast user experience, which is great. Except today, when you make a route static in Next, you can't fetch anything dynamic during the initial request at all. So it's an all or nothing decision, right? If you pre-render a route today, you have to pre-render the whole thing. But pretty much every page has something dynamic. So inevitably, you're going to add some client-side data fetching logic, some new library that's going to complete way after the initial request has already come back. It's going to start waterfalling back and forth between the client and the server. You have to set up API endpoints. You're probably going to bring a library in to make those API endpoints type safe. But here, we didn't have to do any of that. This page isn't dynamic or static. It's both. In other words, it's partially pre-rendered. And partial pre-rendering is the one mode of rendering for all routes when cache components are enabled. No more choosing between static or dynamic. every route is partially pre-rendered. And that error that we saw earlier ensures that every new route you add produces some static content that Next can extract and serve up for a fast initial load. Even if that static content is just some light fallback UI, and most of the page's content is dynamic, it gets the browser to start booting the app instantly. And it doesn't slow down the dynamic data at all, thanks to React's use of server-side streaming. Okay, let's get back to our app. And let's go to the games link up here in the header, which is currently 404. So we'll build out this page. Let's create a new file, a new page module. And we'll fetch the current games, and we'll render the schedule, and then all of the games that are currently playing. And if we save this, again, we'll see an error. That's an old version of the error because we just released Next 16 last night. But it says the same thing as before. So let's do the same thing and unblock our route. We're going to extract the dynamic part into a new component, and we'll render it up here in our page. And then we'll wrap it inside of Suspense. And this time we'll add some light fallback UI. So if we save this and take a look, we see our new beautiful skeleton screen. And then once the fetch calls finish, the data streams in. Easy peasy, right? This is what it's like to work with Next under cache components. It's truly dynamic by default. So there's no more implicit caching. We didn't need to add forced dynamic to our page or cache no store to our fetch calls. As long as we're inside a suspense boundary, we can fetch data without any surprises. And those suspense boundaries ensure that every page in our app can serve its static content instantly and prepare the browser for the dynamic content as early as possible. Now, all this seems great to me. Caching in the app router, it's always seemed confusing. You know, there's all these conventions you have to know about. There's like 9 different config options. So I do like this new explicit approach. But where are my snappy navs? I want my snappy client navs back. Well, let me show you something. If we reload the games page and then click the link to go home, watch what happens. We see an instant render of the static pre-rendered home page, followed by dynamic data. Let's try it from the other direction. Oh, sorry. So that's where the dynamic data comes in. Now let's try it from this direction. Let's imagine we just refreshed on here and we want to go back to the games page. So we'll see as soon as we click, we get an instant nav to the pre-rendered page, and then the content fills in. So how does this work? Well, the answer is prefetching. Thanks to partial pre-rendering, links will prefetch the static content for the upcoming route by default. And this makes total sense, right? We just saw how the new programming model ensures that each route has some static content, so we know that it's both cheap to fetch and that it won't become stale by the time the user actually clicks the link. So the link tag can just prefetch it in advance, and we can have a snappy client nav, an instant client nav that, even though the server was involved originally, by the time we click the nav, it's as if you were in the client doing a client-side navigation. This is awesome. We're able to make use of the browser to get those snappy navs without doing any extra work. We don't have to move any of our data fetching code to the client. We don't need to fork our page component based on whether it's the initial render or a client-side navigation. And we didn't need to create any special loading.tsx file. All we had to do was use suspense and RSCs like normal, and Next gave us instant client-side navs for free. So at this point, you might be wondering, why is this called cache components? What the heck does any of this have to do with caching? And why haven't I seen this new use cache directive yet? Well, if you think about our site so far, what is it that actually let us prefetch the static content for each one of these pages ahead of time? Oops. It's the fact, sorry, I went ahead. It's the fact that we know that this static content can't be stale. That's what let us prefetch it. It's not like the games page that has real-time data, right? It updates every few seconds. this static content can't change because it's based on the code we wrote in our application. It can't change unless we change the code and redeploy the app. So this static pre-rendered content is effectively cached content, right? Wouldn't it be cool if we could cache more of our content? Let's try. If we come back to our home page, well, the standings here only change once a week. In case you don't watch football, they only play once a week, so the only time that they can change is basically once a week. Seems like a good candidate to pre-render ahead of time so that we don't have to fetch and render the standings every time a new person visits the site, right? We can cache it and save some work and make the site a lot faster. So instead of keeping them dynamic, let's remove the suspense boundary, and we'll cache this entire route by adding use cache to the top of the page. If we save and reload, let's see what the behavior is now. Look at that. No partial page, just all the final content available immediately. Let's try navigation from the games page. So we'll load the games page, which still has a loading screen, and then we'll go ahead and click on the home page. Boom. Instant nav to the fully pre-rendered page. So if you think about it, it turns out that we've been working with cached content this whole time. It just starts out as the code in our code base. But with use cache, we can choose to make more and more of our UI cached content. And once we tell Next what's cacheable, it can pre-render it so it can be included in that fast initial load, as well as those snappy prefetched client navs. Pretty awesome, right? Importantly, we haven't had to make any all or nothing decisions here on a route by route basis. If we were to come up to our route layout and say we wanted to add a live score strip of the scripts of the scores up top, but we'll keep them dynamic, so that you can see the latest scores. So we'll wrap it in suspense. Now, if we look at the behavior, we'll see that our standings are still pre-rendered, and then the scores stream in. And same with the home page. If we come back to the home page, let's say we want to add some news stories below the standings table. So we'll write a new component for our news stories that has a fetch, and we'll add it to our tree. We'll put it inside suspense so we have something to pre-render for that part of the UI. But now let's see what happens when we reload the page. Oh, that was important. Let me go back. So we're going to wrap it in suspense so it's dynamic. But we still want to cache the standings table. So what we do is we move use cache down our component tree, right? And this is the composition point that Guillermo was talking about. We don't have to make these all or nothing decisions. It works within the component boundary. And because we don't want everything on the home page to be cached, we can move it down. And now, if we look at what happens when we render the page, let's take a look. We'll save it. And this is our shell. This is our instant static page, pre-rendered content, which still includes the standings. And once the data finishes, both the scores in the layout and the news stories in the homepage stream in. Pretty cool, right? Pretty cool. So we've added more dynamic content without sacrificing the fast initial load or instant client nav to this page. There's so much more I want to talk to you about, but I wanted to focus on this today. And we've seen how use cache lets us partially pre-render our pages into static HTML, right? That's kind of what we focused on today. And we have APIs for regenerating that HTML on demand or after a period of time, similar to how ISR works in the current Next. But one thing I just want to leave you with is that use cache is not just an update to our static rendering API. It's not just a replacement for get static props or a better way to avoid all those crazy caching APIs. Because after all, most of us work on dynamic websites, personalized websites. And dynamic personalized websites need information from the request, right? Like dynamic params, search params, cookies and headers. And that data is never available when we're generating static HTML. But what if we wanted to prefetch pages that depend on those things once users are clicking around our app? What's the answer there? Well, the answer is still use cache. So we're working on APIs that leverage the same caching semantics that use cache and cache life have given us to make it so that your users can click around to fully prefetched pages, even in highly dynamic, personalized apps. And this is what I found so fascinating when joining the team. Just because the app router is server first doesn't mean we have to give up on the kinds of interactions that made us all fall in love with React in the first place. And prefetching is a powerful example of how, but there are many, many more. And now that we have an architecture that avoids the performance cliffs of the past, we know that this new model can take us further than the old one ever could. So that's cache components. They let you pre-render and prefetch your UI for instant navigations in the app router. And we just saw what they felt like to use. Now I'm going to turn it over to Jimmy to show you how they behave once they're deployed.
Hi, I'm Jimmy. I lead the Next.js and TurboPack teams. So like Guillermo said earlier, React really nailed composition. With just a few well-designed primitives, React allows you to build beautiful and functional UIs. With Next.js, we're really trying to extend the same philosophy and apply it to your entire apps. But what does that really mean? Well, one example of that was static generation. That was a game changer. We realized we could pre-compute some pages ahead of time and serve them instantly. That was composition over time. We made apps faster by just doing a little bit more work at build time. But something funny happened along the way. We made those instant responses so attractive that even when the page needed dynamic data, people were willing to wait for the static page and just fetch data from the browser. I don't blame them. Like Sam said, everybody loves those snappy and instant navigations. But in doing so, they introduce hidden latencies to their apps. Since we're now fetching from the browser, every request introduces a new round trip to your database. And one might be acceptable for one request. When multiple of those have to happen sequentially, that latency stacks up, resulting in much longer loading times overall. So we knew one way to optimize these latencies was to be closer to the database via a server. But we still had the problem of the server not being able to respond up until it finished rendering. So we went back to the drawing board and we bet on server components and streaming. Next.js was now able to show pieces of the UI as they became ready, without being blocked on the slowest part of the page anymore. But it still didn't feel as instant as a static page. However, we realized we had all the pieces we needed to come up with something new. Something you might have noticed is how binary the choices were. Pages were either fast and stale, or they were fresh but slow. Turns out, the answer was always more composition. And as Sam showed you, our answer to that was partial pre-rendering and cache components. With a model that allows you to compose both static and dynamic content down to the component level, this allows you to get the best of both worlds, a fast initial UI and optimized data fetching from the server. It's a huge unlock. And I believe it is going to be a big evolution for how you write your Next.js apps. And everything Sam demonstrated earlier just works, whether you're running Next.js on a $5 head snap VPS or in your cloud platform. Partial pre-rendering works just as intended. But let's see how the cache component model can also help when deploying Next.js on a globally distributed platform. See, if your user is in a different region from your server and data, there's still going to be some latency involved. Next.js can do a lot of things, but we can't make life move faster yet. But as we know from the history of the web, the quickest way of serving content is doing it from a CDN close to your user, right? We do it every day for images, fonts, CSS, JavaScript. Well, because our programming model allows us to extract the initial UI for a page, a platform like Vercel can supercharge Next.js rendering and serve the same UI right from your CDN. And we can also stream in the content from your original server. Cache components not only tells Next.js how to compose rendering over time, It also lets you compose it over space. So regardless of where your users are on the planet, we now brought latency down to its theoretical minimum. That's the kind of innovation that's at the core of our work at Vercel. We want to build a web framework that works for everyone, but also we want to push the boundary of what's possible on a modern infrastructure. So you might be wondering, does Next.js come with a tutorial on how to do this? Well, not really. We're so focused on building the app router, we didn't spend as much time sharing that philosophy as clearly as we should have. And we heard it loud and clear. Even though lock-in was never our intention, a lot of people claim it was by design. But Next.js has always been open source, and it still drives everything the team does. So it's not just about having our embarrassing PRs in public. It's about building a framework that can be used and supported by everyone to the best of their abilities. Rising tide lifts all boats, and the ideas we're pushing with Next.js are meant to scale beyond Vercel, even beyond Next.js. So we want you to have the best possible experience with Next.js, regardless of your platform choices. So we've been building something new. The build deployment adapters API. It's a clear and explicit contract between Next.js and the platform that runs it. We're sharing all the primitives that we use to deploy Next.js at scale. And it's all there in a stable and version and documented API. That information was already present when running Next build, right? But there wasn't really any guide on how to enhance Next.js the same way Vercel does. So this API is meant to be a framework for deploying Next.js to its full capacities. We want to provide you with a clear spec, fewer surprises, and hopefully a stronger foundation to invest on. Another piece of the puzzle is, well, once you build your adapters, how do you verify that they actually work as intended? Well, we're also sharing the same test suite that we use to validate all Next.js features on Vercel, and our goal is to create transparency for our users, so that when they adopt a new platform, they can verify that Next.js works well. And this also helps us identify which area of the ecosystem we can better help on. We didn't do this alone. Earlier this year, we created a working group with contributors from AWS, Cloudflare, Firebase, Netlify, and OpenNext. We gathered the pain points they had when hosting Next.js, and from there we crafted an RFC and refined the design together. And so what I've announced today is a result of that collaboration. With Next.js 16, the deployment adapters ships in alpha. And we want your feedback as we migrate the ecosystem gradually. We're also using the same API on Vercel with our own adapter. We want to play fair and with the same rules we're imposing to our partners. Our goal is to use this as the foundation for a more collaborative Next.js, one where the ecosystem benefits from all the work we continue to do at Vercel. And so to everyone in our working group, thank you for your time, for your feedback, and all the engineering hours you've invested into making this possible. If you're a platform provider who wants to better support Next.js, we'd love to work with you. So today, we talked about 3 long-term bets for Next.js. TurboPack, which was our bet on incrementality and a better developer experience. Cache components, our bet on a programming model that unlocks new levels of performance with composition. And the deployment adapters API, which was our bet on an open Next.js and one that scales beyond Vercel. These ideas have been in motion for years, and they're finally here. Next.js 16 is available today, with TurboPack as the default, cache components as an opt-in, and we'll be sharing guides, examples, and migration path to help you make the most of them. I'm incredibly proud of the work the team has done for this release, and I'm extremely excited to see what you will build next. Thank you.
Everybody, thank you. This conference and this release feels like an inflection point for the framework, for the ecosystem, and for the future of coding. We talked a lot about the future of coding with LLMs and agents. So we decided to bring something even better than agents, the people behind creating the agents. So we'll have Aryan from Vercel, who's working on V0, Fawad from OpenAI, working on Codex, Matten from Factory AI, working on Droid, and Swix from Latent Space, who's going to moderate this panel, and they're all going to talk about this future that's coming, and in many ways is here today. So let's give it up for them, and thank you again.
That is good music for walk-on.
Very nice.
All right. Welcome to the Future of AI Coding panel. Thank you for reading the memo that you have to wear all black. Okay, so I do want to cover a little bit of introductions. I know each of you in different ways, but maybe the audience fully doesn't quite. Matan, why don't you go first? What are you proudest of? Like, what is Factory's position to like the broader world in AI coding?
Yeah, so at Factory, our mission is to bring autonomy to software engineering. And what that means more concretely, we have built end-to-end software development agents called droids. They don't just focus on the coding itself, but really the entire end-to-end software development lifecycle. So things like documentation, testing, review, kind of all the ugly parts so that you can also do the more fun parts like the coding itself. And for the parts of the coding you don't want to do, you can also have the droids do that. So we build droids.
Build droids. And OpenAI obviously needs no introduction, but your role on the Codex team, I saw you pop up on the Codex video. That's how I knew there was you working on it. But how do you think about Codex these days, since it's expanded a lot?
Yeah, so earlier this year, we launched our first coding agent, which I worked on Codex CLI, bringing the power of our reasoning models into people's computers. Then we released Codex Cloud, where you could actually distribute and kind of delegate those tasks to work in the cloud. And over the last some odd months, we've been unifying these experiences so they work as seamlessly as possible. So a lot of our focus is around how do we make the fundamentals, the primitives, as useful as possible. We just released at Dev Day Codex SDK. So I think one of the key directions we've been seeing is not just using coding or code executing agents for coding, but also for general purpose tasks. And so whether it was ChatGPT agent, which I worked on earlier this year, that actually executes code in the background to accomplish some tasks, but starting to enable our developers to build on top of not just the reasoning models, but also things like sandboxing and all the other primitives that we built into Codex.
Awesome. V0?
Yeah, the goal of V0 is to enable developers to do preview-driven agentic programming. So today, when you build web apps, you probably have an agent open, your IDE open, so some kind of code, and then a preview of what you're actually building. Usually you're running dev server. With V0, our goal is to allow you to just have an agent running and directly prompt against your running app. And that's how we think the future of DX is gonna pan out.
Okay, awesome. And everyone has different surface areas in which to access your coding agents. So I think one of the things that we kind of want to kick off with is how important is local versus cloud? You started local, went cloud. You started cloud, went local. You're cloud only for now. What's the split? Is everyone just going to merge eventually?
Yeah, so maybe I can start there. So I think at the end of the day, the point of these agents is that they are as helpful as possible, and they have a very similar silhouette to that of a human that you might work with. And you don't have local humans and remote humans that are like somehow, this one only works in this environment, this one only works in that environment. Generally, humans can be helpful whether you're in a meeting with them and you come up with an idea, or you're sitting like shoulder to shoulder at a computer. So I guess asymptotically, these need to become the same. But I think in the short term, remote is typically, what we're seeing is it's typically more useful for smaller tasks that you're more confident that you can delegate reliably, whereas local is when you want to be a little bit closer to the agent. It's maybe some larger task or some more complicated task that you're going to kind of actively be monitoring. And you want it to be local so that if something goes wrong, you don't need to pull that branch back down and then start working on it, but instead you're right there to guide it.
Yeah.
Yeah, maybe I'm just greedy, but I want both. And I think having a modality, to Matan's point, where I like to think about what are the primary forms of collaboration that I'm used to and I enjoy with my coworkers. Often that starts something like a whiteboarding session, and maybe we're just like jamming on something in a room. When we were building, I think a good example was agents.md, which is our kind of custom instructions intended to be generic across different coding agents. The way that started was Romain and I were just in a room coming up with this idea, and then we just started whiteboarding, and then took a photo, and then kicked it off in Codex CLI locally, just to kind of workshop a Next.js app that we could work on. Went to lunch, came back. It had a good amount of the kind of core structure, and then from there we were able to iterate a little bit more closely. So having that kind of pairing and kind of brainstorm style experience, and then I think to that second point about what kind of tasks you delegate to, I think historically smaller, more narrowly scoped tasks where you're very clear about what the output is kind of the right modality if you're doing a fire and forget. But I think what we're starting to see with, we just launched GPT-5 Codex about 2 months ago now, and I think one of the main differences is that it can actually do these longer running, more complex, more ambiguous tasks, as long as you are clear about what you want by the end. So it can work for hours at a time. I think that shift as models increase in capability will start to enable more kind of use cases.
Yeah.
Yeah, I think there are 3 parts of making an agent work. There's the actual agent loop, there are the tool calls it makes, and then the resources upon which the tool calls need to act. Whether you go cloud or local first is based on where those resources are, right? If you're trying to work on a local file system, those are the resources you need to access. It totally makes sense that your agent loop should run locally, right? If you're accessing resources that typically exist in the cloud, you're pulling from GitHub, directly from like third-party repo of some kind, then it makes sense for your agent to start off in the cloud, right? Ultimately, though, these resources exist in both places, right? Every developer expects an agent to be able to work both on the local file system as well as on an open PR that might be hosted on GitHub. And so it doesn't really matter where you start, I think. Everyone is converging at the same place, which is that your agent loop needs to be able to run anywhere. Your tool calls need to be able to be streamed from the cloud locally or from the local back up to the cloud. And then it all depends on where the resources you actually want to act on are located.
Yeah, awesome. Okay, so we were chatting off stage, and we were like casting around for spicy questions and stuff. So I really like this one, and I think it's very topical. Do you guys generate slop as a living? Like, are we in danger of potentially being in a hype bubble where we believe that this is like a sustainable path to AGI?
I mean, I think to start, you could say that one man's slop is another man's treasure, which to some extent might be true. If, for example, you have, I don't know, like let's suppose you had a repo that had no documentation whatsoever. You could use, many of the tools that we've been talking about to go and generate documentation for this repo. Now, is it going to be the most like finely crafted piece of documentation? No. But is it providing alpha? Yes, in my mind, because having to like sift through some super old legacy code base that has no docs is a lot harder than looking through some somewhat slopified documentation. And so I think the big thing is it's figuring out where you can use these tools for leverage, and the degree to which it's slop, I think also kind of depends on how much guidance you provide. So if you just say like, build me an app that does this, like you're probably going to get some generic slop app that does.
It's purple.
Yeah, that's blue, purple like fade. Yeah. Whereas if instead you're like very methodical about exactly what it is that you want, you provided the tools to actually run tests to verify some of the capabilities that you're requesting, I think that makes it much more structured to a similar extent that if you were to, hire some junior engineer onto your team and you just say, hey, go do this. Like they're probably going to yield some like median outcome because they have no other specification to go off of. And it's pretty ambiguous, like what you actually want done.
I think the keyword there is leverage, right? Like what AI coding agents allow you to do is do 10x more than you would be able to do yourself with a pretty high floor, right? So if you plot skill level against how useful an agent is or how likely it is, how useful it actually is in generating non-slop, there's probably a like pretty low floor. If you have no skill, you have a pretty high floor still, right? Agents are pretty good just out of the box. If you don't know anything about development, the agent is going to do much more than you could possibly do. But as you get to higher and higher skill levels, senior and principal and distinguished engineers actually use agents differently. They're using it to level up the things they could already do. A principal engineer might be able to write manually 5,000 lines of code a day. With agents, they can write like 50,000 lines of code a day. And it really operates at the level of quality of the inputs and the knowledge that you put in there. So I think we're slowly raising the floor over time by building better agents. But I do think it's a form of leverage. It's a way for you to accelerate the kinds of things you can already do them faster. And for folks who don't have skills, that's when you can actually really raise the floor of what it can be do.
Absolutely. And just to add on to both of these points, I think they're tools and amplifiers of craft. If you have it, you can do more of it. If you don't, it is just harder, but it does raise the floor. I think that's really worth calling out. I think for folks who are just trying to build their first prototype, they're trying to iterate on an idea. That example I was mentioning earlier, it's not that I couldn't make a front end that kind of is like a content-driven site, but I just didn't have time, and it was more fun to just draw on a whiteboard, have a conversation, and then kick that off to an agent. But I think one of the interesting examples of this was when we were building much earlier iterations of Codex well over a year ago, and we were putting in front of two different archetypes, folks who did a lot of kind of product engineering where they're used to using kind of local in the inner loop style tools where they're used to just chatting and maybe iterating. And then a completely different modality when we talk to folks on the reasoning teams where they would sit for maybe 5 minutes just defining the task and have like an essay length like word problem for the agent to go off and do, and then it would work for an hour. And that was effectively O1 or earlier kind of versions of it. And I think the interesting part there was just the way that people would approach giving the task to the agent was completely different based on their understanding of what do they think it needs. And so I think really anchoring on specificity, being really clear about what you want the output to be. And then I think there's a broader item that is a responsibility on both us as builders of agents and folks training models to really raise that floor and to ensure that the ceiling for people with high craftsmanship, with high taste, are able to exercise that in the way that they see fit.
I think actually something that you mentioned brought this idea to mind that we've started to notice. So our target audience is the enterprise. And something that we've seen occur time and again is that there's a very interesting bimodality in terms of adoption of agent native development. And in particular, normally earlier in career developers are more open-minded to start building in an agent native way, but they don't have the experience of managing engineering teams. So they're maybe not the most familiar with delegation in a way that works very well. Meanwhile, more experienced engineers have a lot of experience delegating. They know that, hey, if I don't specify these exact things, it won't get done. And so they're really good at writing out that paragraph, but they're pretty stubborn and they actually don't want to, change the way that they build, and you're going to have to, pry Emacs out of their cold dead hands. So it's an interesting balance there.
So funny you say that. Similar thing we've seen on the enterprise is, senior engineers, higher up folks will write tickets. So they'll actually do the work of writing out all the spec of what needs to be done. They'll hand it off to a junior engineer to actually do. The junior engineer takes that super well-written ticket and gives it to the agent to do, right? So you're just arbitraging the idea that the junior engineer will actually do the agent work because they're more comfortable doing that. But the senior engineer is the person who's actually really good at writing the spec, very good at understanding what are the architectural decisions we should be making, and putting that into some kind of ticket.
Yeah. For those who don't know, Matan and Factory in general have been writing and advocating about the agent native development, so you can read more on their website. I think one thing, by the way, I do want to issue maybe one terminology thing, which is raise the floor for you is a good thing, but I think actually other people say lower the floor and also mean the same thing. It basically just it's about skill level and what they can do, and just giving people more resources for that. I think also the other thing is a lot of people are thinking about the model layer, right? Obviously, you guys own your own models. The two of you don't. And I think there's a hot topic of conversation in the Valley right now. Airbnb, Brian Chesky has said that most of the Valley relies on Quen apparently. How important is open models to you guys? And you can, Fouad, you can chime in as well. But how important is open models as a strategy for both of you?
I'd be curious to hear from you first.
Yeah.
Love open models. I think one of the important things about, so just before you talk about models, I think openness is really key to, I think, a sustainable development lifecycle where with Codex CLI, we open sourced it out the gate. And part of the priority was understanding that an open model was coming down the line, we wanted to make sure that we could as best document how to use our reasoning models. We saw a lot of kind of confusion about what kind of tools to give it, what the environment should be, the resources. And so we wanted to make sure that that was as clear as possible, and then also make sure that it worked well with open models. So I think there are definitely a lot of use cases, especially when you get into kind of embedded use cases, or where cases where you don't want the data to leave the perimeter. There's a lot of really good reasons for why you would want to do that. And then I think the benefit of kind of cloud-hosted models, and that's what we see with a lot of open models, they end up being, they're not run on device, but they're actually cloud-hosted anyway, maybe for efficiency, maybe for cost, there's still a lot of value in just the pure intelligence that you get from using a much bigger model. And that's why we see people really gravitate towards models from O3 to GPT-5 to GPT-5 codecs. There's still a lot of value in that. Now we see that overhang still kind of comes, it resolves itself, where every couple months there's a new, very small, very, very impressive model. And I think that's the magic. If we just consider the beginning of this year, we had O3 Mini as kind of the frontier and where we are now. And so, yeah, I think that there's a ton of value in open models, but still, I think personally, from a usage perspective, more value in using the kind of cloud-hosted ones.
Yeah, I'll just interject a bit. Fouad actually cares a lot about privacy, security, agent robustness, and so you can if you run into him, talk to him more about that. But for both of you guys, maybe you want to start off with what's your ballpark of open model token percentage generated in your respective apps, and is it going to go up or down?
So I guess, so maybe to start, because I think what you said is really interesting. So a couple of weeks ago, when we released our factory CLI tool, people were really interested because we also released with it our score on this benchmark called Terminal Bench. And one of the first asks was, can you guys put open source models to the test? Because our Droid agent is fully model agnostic. So immediately people were like, throw in the open source models and like show us how it does. And I think something that was particularly surprising was that the open source models, and in particular GLM, were really, really good. They were in fact like obviously less performant than the frontier models, but not by a huge margin. I think, so one thing that was noteworthy though, was when we benchmarked the open source models, of the 7 that were at the top, 1 of them was made in the United States by yours truly over here, which I think is kind of a shame. Like the fact that by far all of the frontier models, it's United States across the board. But then when it comes to open source, we're really dropping the ball there. So I think that's one thing that's noteworthy, and I think something that, at least when I saw that, I really think there should be like a call to arms there in terms of changing that. Because I think, to answer your question, what we found is that since we released support for open source models, the percent of people that are using open source models has dramatically risen, partially because of cost, and that it's allows you, like, let's say in that documentation example, maybe you want to generate docs, but you don't want it to be like on super high reasoning, like to the max, like cost you $1,000, but you just want to get like some initial first pass in. And also people like having a little bit more control, and I feel like they get a lot more of that control with some of these open source models, both controlling the cost and just like kind of observability into what's actually happening there. So I think the demand has grown to a point where I actually did not expect a year ago. I think a year ago I was less bullish on open source models than I am now. Open weight, but yeah.
Yeah, I think we use both open source and closed source models in our overall agent pipeline. And I think the way we think about them is there's 2 different use cases for an LLM call. One is you want state-of-the-art reasoning. It's a very, very open-ended question. You actually don't know what the answer is. The goal function is not super well defined. In those cases, closed source models are still state-of-the-art when it comes to reasoning and intelligence. We use closed source models pretty much exclusively for those kinds of use cases. There's a second use case where we have a more niche task with a much clearer goal function. And in those cases, we almost always try to fine-tune an open source model. We're okay taking a 20% cut hit maybe in terms of reasoning ability, so that we can actually fine-tune a very, very specific use case. And I think we found that open source models are catching up very, very, very fast. A year and a half ago, it was like unthinkable for us to be able to use open source models as part of V0's pipeline. Today, every single part of the pipeline, we're like, okay, can we bring open source models into this? Can we replace what we're doing currently with closed source state-of-the-art frontier models with a fine-tune of an open source model. And we've seen a ton of success with Qwen, Kimi K2, other kinds of models like that.
Yeah. Yeah, I'll call this out as one of the biggest deltas I've seen across everyone, which is at the start of this year, I did a podcast with Ankur from BrainTrust, and he said that open source model usage is roughly 5% across what BrainTrust is seeing and going down. And now I think like reasonably it's going to go to like between like the 10 to 20% range for everybody.
I do think it's interesting that even closed source models are investing more heavily into their small class models, right? The Haikus, GPT-5 minis, Gemini Flashes of the world, which I think also is like that model class is what competes with open source the most. It's the small model class competing against a fine tune of an open source model.
And I also think there are some use cases where it will just be overkill to use a frontier model. And if it is overkill, you are then just going to obviously be incentivized to use something that's faster and cheaper. And I think part of I think this delta in terms of percent usage is like, there is this threshold of like when open models cross the threshold of like for most tasks, it's actually enough. And then for some niche tasks, you need like the extra firepower. I think we're really getting there with some of these open models, which is why I would suspect we'll see more usage going forward.
Yeah, awesome. That's very encouraging. So we have a bit of time left. I prepped you guys with the closing question, which is, what's something that your agents cannot do today that you wish they could do that they'll probably do it next year?
Am I going first? Okay. Yeah, I think that what we've seen over the last year, just maybe starting as a reference point, with O1 a little over a year ago, or O1 preview, what we've seen from then, when I was using very early checkpoints of that model, it was great relative to 4.0, but still had so much left to be desired. I wouldn't put it. I was on the security team at the time, and there was a lot of work and tasks that I just couldn't delegate to that model. And when we compare to today, where I can take a pretty well-defined task, like maybe it's like 2 sentences, a few bullet points, to your point, like here are the gotchas that I think you'll probably get stuck on, and then come back and 30 minutes later, an hour later, it's done it. We've seen cases where it's running for many hours, maybe even 7 to 8 hours, effectively a full workday that I spend a lot of my day in meetings, and so don't necessarily have that kind of solid block of time. But that's only half of what engineering is really about. Part of it is coding, part of it is architecting and troubleshooting and debugging. The other half of the problem is writing docs, is understanding the system, convincing people. And so I think what we'll start to see is this kind of super collaborator where what we want to bring, whether it's in Codex or these other kind of interfaces through the Codex model, is the ideal collaborator that you want to work with, the person you first go to, that favorite coworker that you want to kind of jam on ideas with. That's really what we want to see at least with Codex.
I think for us, we've seen a bunch rapid progression on 2 different fronts. The first is, how many steps can you reasonably expect an agent to be able to do and get reasonably good output? Last year, there's probably 1, maybe max 3, right? If you wanted reliable output with over 90% success, you're probably running 1 to 3 agent steps. Today, most tools run 5 to 20 with no really great reliability rates, over 90% success. I think next year we're going to enter the like 100 plus, 200 plus. Let's run tons of steps all at once, have long running tasks for multiple hours, and be confident that you'll get an output at the end that will be useful. The second is in terms of what resources can be consumed. A year ago, it was whatever you are putting into the prompt form. Like that was pretty much it. Today, you can now configure external connections, via MCP or by making API calls directly in your application. You can kind of do that if you're knowledgeable, you have the ability to configure things. And I think in a year from now, those will just happen. Like it will just work. The goal is like you should not need to know what sources of context you need to give the agent. The agent will actually go and find those sources of context proactively. We're kind of starting to see that already today, but I'm still not really confident that's very reliable and useful today. I think by next year, that'll be the default mode.
Yeah, I would agree with that. I think agents can do basically everything today, but the degree to which they do so reliably and proactively is, I think, the slider that is going to change. But that's a slider that's also dependent on the user. Like if you're a user who's like not really like changing your behavior and meeting the agent where it is, then you might get lower reliability and proactivity. Whereas if you kind of set up your harness correctly or set up your environment correctly, it'll be able to do more of that reliably and more proactively.
Yeah, amazing. Well, we're out of time. My contribution is computer vision. Everyone try Atlas. Everyone try like more computer vision use cases. But thank you so much for your time.
Thank you.
Thank you for having us.
Please welcome to the stage Crayon Consulting web developer Aurora Scharf.
Okay, hello everyone. My name is Aurora. I'm a web developer from Norway. I work as a consultant at Crayon Consulting in Oslo, and I'm actively building with the Next.js app router in my current consultancy project. Today, I'm going to be teaching you patterns regarding composition, caching, and architecture in modern Next.js that will help you ensure scalability and performance. Let me first refresh the most fundamental concepts for this talk: static and dynamic rendering. We encounter them both in the Next.js app router. Static rendering allows us to build faster websites because pre-rendered content can be cached and globally distributed, ensuring users can access it quicker. For example, the Next.js Conf website. Static rendering reduces server load because content does not have to be generated for each user request. Pre-rendered content is also easier for search engine crawlers to index, as the content is already available on page load. Dynamic rendering, on the other hand, allows our application to display real-time or frequently updated data. It also enables us to serve personalized content, such as dashboards and user profiles. For example, the Vercel dashboard. With dynamic rendering, we can access information that can only be known at request time. In this case, which user is accessing their dashboard, which is me. There are certain APIs that can cause a page to dynamically render. Usage of the params and search params props that are passed to pages or their equivalent hooks will cause dynamic rendering. However, with params, we can predefine a set of pre-rendered pages using generate static params, and we can also cache the pages as they're being generated by users. Furthermore, reading incoming request cookies and headers will opt the page into dynamic rendering. Unlike with params, though, trying to cache or pre-render anything using headers or cookies will throw errors during build, because that information cannot be known ahead of time. Lastly, using fetch with a data cache configuration no store will also force dynamic rendering. So these are the few. There are a few more APIs that can cause dynamic rendering, but these are the ones we most commonly encounter. In previous versions of Next, a page would be rendered either as fully static or fully dynamic. One single dynamic API on a page would opt the whole page into dynamic rendering. For example, doing a simple auth check for the value of a cookie. By utilizing React Server components with suspense, we can stream in dynamic content like a personalized welcome banner or recommendations as they become ready, and provide only fallbacks with suspense, while showing static content like a newsletter. However, once we add in multiple async components on a dynamic page, like a feature product, they too would run at request time, even though they didn't depend on dynamic APIs. So to avoid blocking the initial page load, we would suspend and stream those components down as well, doing extra work, creating skeletons, and worrying about things like cumulative layout shift. However, pages are often a mix of static and dynamic content. For example, an e-commerce app, dependent on user information while still containing mostly static data. Being forced to pick between them, between static or dynamic, causes lots of redundant processing on the server, on content that never or very rarely changes, and isn't optimal for performance. So to solve this problem, at last year's Next.js Conf, the use cache directive was announced. And this year, as we saw in the keynote, it's available in Next.js 16. So with use cache, pages will no longer be forced into either static or dynamic rendering. They can be both. And Next.js no longer has to guess what a page is based on whether it accesses things like params. Everything is dynamic by default, and use cache lets us explicitly opt into caching. Use cache enables composable caching. We can mark either a page, a React component, or a function as cacheable. Here, we can actually cache the feature products component because it does not need request time processing and does not use dynamic APIs. And these cache segments can further be pre-rendered and included as a part of the static shell with partial pre-rendering, meaning the feature products is now available on page load and does not need to be streamed. So now that we have this important background knowledge, let's do a demo, an improvement of a code base with common issues often encountered in Next.js apps. These include deep prop drilling, making it hard to maintain or refactor features, redundant client-side JavaScript and large components with multiple responsibilities, and lack of static rendering, leading to additional server costs and degraded performance. So yeah, let's begin. And give me one sec over here. Great. So this is a pretty simple application. It's like inspired by an e-commerce platform. And let me do like an initial demos here. So I can load this page. I have like some content like this feature product. I have feature categories, different product data. There's also this browse all page over here where I can see all of the products in the platform and page between them. Then we have this about page over here, which is just static. I can also sign in as a user, and that will log me into my user, and also get then personalized content on my dashboard here, like, for example, recommended products or this personalized discounts here. So notice here there's a pretty good mix. Also, one more page that I forgot to show you. The product page, the most important one. Also here we can see product information and then save it if we like for our user. So notice that there's a pretty good mix here of static and dynamic content in this app because of all of our user-dependent features. Let's also have a look at the code, which would be over here. So I'm using the app router here, of course, in Next.js 16. I have all of my different pages, like the about page, the all page, product page. I also have, I'm using feature slicing here to keep my app folder clean. I have like different components and queries talking to my database with Prisma. So yeah, and I purposely slowed all of this down. So that's why we have these really long loading states, just so we can easier see what's happening. So the common issues that we wanted to work on here that we actually have in this application was deep prop drilling, making it hard to maintain and refactor features, excess client-side JavaScript, and lack of static rendering leading to additional server cost and degraded performance. So the goal here of the demo is basically just to improve this app with some smart patterns regarding composition, caching, and architecture to fix those common features and make it faster and more scalable and easier to maintain. So let's begin with that. The first issue we want to fix is actually related to prop drilling, and that would be over here in the page. Notice right here I have this logged in variable at the top here. And you can see I'm passing it down to a couple of components. It's actually being passed multiple levels through into this personal banner. So this is going to be making it hard to reuse things here because we're always having this logged in dependency for our welcome banner. So with server components, the best practice would be to actually push data fetching down into the components that's using this and resolve promises deeper into the tree. And for this, get is authenticated. As long as this is using either fetch or something like React Cache, we can deduplicate multiple calls of this, and we can just reuse it anywhere we like inside our components. So that will be totally fine to reuse. So now we can actually move this into the personalized section here, and we're not going to need this prop anymore. And just put it directly, in here. And we're not going to need to pass this anymore. And since we're now moving this asynchronous call into the personalized section, we're no longer blocking the page. We can go ahead and suspend this with just a simple suspense here. And we're not going to need this fallback. As for the welcome banner, I suppose we're going to do the same. But trying to use get the logged in variable here or value doesn't work, right? Because this is a client component. So we need to solve this a different way. And we're going to do a pretty smart pattern here to solve this. We're actually going to go into the layout and wrap everything here with a auth provider. So I'm just going to put this around my whole app here and get this logged in variable over here. And I definitely don't want to block my whole root layout. Let's go ahead and remove the await here and just pass this down as a promise into this auth provider. And this can just contain that promise. It can just be chilling there until we're ready to read it. So now we have this set up. That means we can actually go ahead and we'll get rid of this prop first of all. And we'll get rid of this one drilling down to the personal banner. And we'll get rid of the prop drilling also here, or the signature. And now we can use this auth provider to fetch this logged in value locally inside the personal banner with use auth, with that provider we just created. And read it with use. So this will actually work kind of like in a wait where we need to suspend this while it's resolving. So now I just co-located that little small data fetch inside the personal banner, and I don't have to pass those props around. And while this is resolving, let's just go ahead and suspend this one also with a fallback, and let's just do a general banner over here to avoid any weird cumulative shift. And finally, also get rid of this one. So now this welcome banner is composable, it's reusable, we don't have any weird props or dependencies in the homepage. And since we're able to reuse this so easy, let's actually go ahead and add it also to this browse all page over here, which will be here. And I can just go ahead and use it over here without any dependencies. So through these patterns, we're able to maintain good component architecture, utilizing React Cache, React Use, and make our components more reusable and composable. All right, let's tackle the next common challenge, which would be excessive client-side JavaScript and large components with multiple responsibilities. Actually, that's also in the all page here. And again, we'll have to work on this welcome banner. It's currently a client component. And the reason it's a client component is because I have this very simple dismissed state here. I can just click this. It's a nice UI interaction. That's fine. What's not so fine, though, is because of that, I converted this whole component into a client-side component, or a client component. And I even use SWR to client-side fetch. I have now this API layer here. I don't have type safety anymore in my data. Yeah, this is not necessary. And we're also breaking the separation of concerns here because we're involving UI logic with data. So let's go ahead and utilize another smart pattern to fix this. It's called the donut pattern. Basically, what I'm going to do is extract this into a client-side wrapper. So let's create a new component here, and let's call it banner container. And this is going to contain our interactive logic with this use client directive. We can create the signature. We can paste everything we just had earlier. And instead of using these banners, I'm just going to slot a prop here, which is going to be the children. So this is why it's called a donut pattern. We're just making this wrapper UI logic around server-rendered content. Or it could be server-rendered content. And then since we no longer have this client-side dependency, we can go ahead and remove the use client. We can use our isAuth asynchronous function here instead. We can make this into an async server component. We can even replace client-side fetching with server-side fetching. So let me go ahead and just get the discount data directly here. Discount data. And just utilize our regular mental model like before with type safety. And that means I can also delete this API layer that I don't want to work with anyway. Finally, for the isLoading, we can just export a new welcome banner here with our donut pattern banner container containing server-rendered content. And that means we don't need this isLoading anymore. So we basically refactored this whole thing into a server component, right? And extracted the UI logic for it. But what is that? It looks like I have another error. So this is actually because of motion. Do you use motion? It's a really great animation library, but it requires the use client directive. And again, we don't have to make this use client just for an animation. We can create, again, a donut pattern wrapper and just extract wrappers for these animations. And that means we don't have to convert anything here into client side. And I'm probably missing something down here. Yep. There we go. So now everything here has been converted to server. We have the same interaction. We still have our interactive logic here, but now we have this one way to fetch data. And we have a lot less client-side JS. Actually, I'm using this donut pattern myself for this UI boundary helper, which looks like this. Do you see that? So this kind of shows, again, what I mean, right? With the donut pattern, we have this client component around a server component. I also marked a lot of my other components with this UI helper here. Also here, I have more server components. Let's go ahead and improve those also, since we're getting pretty good at this by now. They are in the footer. These categories, I have this nice component fetching its own data, and I just want to add this show more thing, just in case it gets really long. And with a donut pattern, I can just wrap a show more component here. And this will contain my UI logic. And it looks like this, right? Pretty cool. And this is now containing the client logic, allowing us to use state. We're using the children, count, and to array to slice this. And what's so cool here is that these two are now entirely composable, reusable components that work together like this. So this is really the beauty of these patterns that we're learning here. You can use this for anything. I also use it for this modal over here. yeah, just remember this next time you're considering adding any sort of client logic to your server component. OK, we know the DOTM pattern. We know how to utilize it to create these composable components and avoid client.js. So we can move further to the final issue. Let me go ahead and close this again. So that would be with lack of static rendering strategies, right? Looking at my build output, I actually have every single page be a dynamic page here. So that means that whenever I load something here, this is going to be running for every single user. Sorry. Every single user that opens this is going to get this loading state. It's going to be wasting server costs, making the performance worse. And that means also that something inside my pages is causing dynamic rendering or forcing dynamic rendering for all of my pages. Actually, it's inside my root layout. I don't know if you experienced this. It's over here. In my header, I have this user profile. And this is, of course, using cookies to get the current user. And that means that everything else is also dynamic rendered. Because, again, pages could be either dynamic or static, right? This is a pretty common problem and something that has been solved before in previous versions of Next. So let's just see what we might do. One thing we could do is create like a route group and split our app into like static and dynamic sections that would allow me to extract my about page. I could render this statically. It's OK for some apps, but in my case, the important page is the product page, and this is still dynamic, so not really helpful. How about this strategy? So here I'm creating this request context param, encoding a certain state into my URL, and then I can use generate static params to generate all of the different variants of my pages. That would actually, combined with client-side fetching the user data, allow me to get this cache hit on my product page. Definitely a viable pattern. It's recommended by the Vercel Flags SDK, called the pre-compute pattern, I think. But this is really complex, and I have like multiple ways to fetch data. And actually, I don't want to rewrite my whole app into this. So what if we didn't have to do any of those workarounds? What if there was a simpler way? Well, there is. Let's get back to this our application again. So we can actually go to the next config and just enable cache components. Ooh, nice. OK, and what this does, as you know from the keynote, will actually opt all of our asynchronous calls into request time or dynamic. And it will also give us errors whenever we have some asynchronous call not suspended. And it will give us this use cache directive that we can use to granularly cache either a page, a function, or a component. So yeah, let's go ahead and utilize this. We can begin with the homepage here. Let's have a look. So again, I have this mix of static and dynamic content. I have my welcome banner for me, something for you, also for me. Let's have a look at that with this UI helper again. So for example, the banner is dynamically rendered, right, with this over here. Whereas I mark this as hybrid rendering because the hero, it's fetching this asynchronous thing, and it's going pretty slowly, but it doesn't depend on any sort of user data or dynamic APIs. So that means that everything that is hybrid rendered here can actually be reused across requests and across users. And we can use the use cache directive on that. So let's add the use cache directive here and mark this as cached. And that will allow me to, whenever I reload this page, I didn't save this. There we go. It will not reload this part, right? Because it's cached. It's now static, right? And there's also other related APIs, like the cache tag to allow me to tag this or validate the specific cache entry granularly, or define my validation period. But for this demo, let's just focus on the plain directive. Now that I have this use cache directive, I can actually remove my suspense boundary around this hero. And that means, well, what this will do is that partial pre-rendering can actually go ahead and include this in the statically pre-rendered shell, so that this hero will, in this case, be a part of my build output. Let's do the same thing for everything else on this page that can be shared. For example, I have this feature categories over here. Let's go ahead and do the same there. And add the use cache directive and mark this as cached, like that. And we can remove the suspense boundary. We're not going to need this anymore. Same for the feature products. Let's add use cache and mark this as cached. Oops. and then remove the suspense boundary. So notice how much complexity I'm just able to remove here. I don't have to worry about my skeletons, my cumulative layout shift that I was doing before. And the page is no longer, we don't no longer have this page level static versus dynamic limitation. So now when I load this page, you'll see everything here is cached except for this truly user-specific content. Right. So that's pretty cool. Let's go to the browse page and do the same thing over there. Yeah, I already marked all of my boundaries here, so you can easily understand what's happening. And I want to at least cache these categories. Looks like I'm getting an error, though. Maybe you recognize this. So it means I have a blocking route, and I'm not using the suspense boundary when I should be doing it. Refreshing this, it's true, huh? This is really slow, and it's causing performance issues and bad UX. So this is great. Use cache or cache components is helping me identify my blocking routes. Let's actually see what's happening inside that. So this is the problem, right? I'm fetching this category's top level, and I don't have any suspense boundary above it. Basically, we need to make a choice. Either we add a suspense boundary above, or we opt into caching. Let's do the simple thing first and just add a loading TSX here. And let's add a loading page over here, some nice skeleton UI. That's pretty good. It resolved the error, but I don't have anything useful happening on this page while I'm waiting. I can't even search. So with cache components, dynamic is like, or static versus dynamic is like a scale. And it's up to us to decide how much static we want in our pages. So let's shift this page more towards static. And just delete this loading TSX again. And then utilize the patterns that we were learning earlier to push this data fetch into the component and co-locate it with the UI. So move this down into my responsive category filters here. I have two because of responsive design. I can actually go ahead and just add it here. Oops. And import this. I don't need this prop anymore. Actually, my component is becoming more composable. And instead of suspending it, let's just add the use cache directive. And that should be enough. So notice how I'm being forced to think more about where I'm resolving my promises and actually improving my component architecture through this. I don't need to suspend this. This will just be included in the static shell here. The product list, let me just keep this fresh. So I can reload that every time. Whereas the categories at the bottom, I also want to cache this. So let's go ahead and go to the footer. And since I'm using the donut pattern over here, this can actually be cached, even though it's inside this UI, part of the UI that's interactive. So this is totally fine. So that pattern was not only good for composition, but also for caching. I think I have one more error there. Let's see what that is. Still have this error. This is actually because of these search params. Search params, as we know, is a dynamic API. I can't cache this, but I can resolve it deeper down to reveal more of my UI and make it static. So let's go ahead and move this down, pass it down as a promise to the product list. We'll make this typed as a promise over here, like that. Let's resolve it inside the product list, use the resolved search params over here and over here. And since this is suspended, here, the error will be gone. So reloading this, the only thing that's reloading here is just the part that I picked specifically to be dynamic. Everything else can be cached. And that means that I can interact with my banner or even search because that part has been already pre-rendered. All right, let's do the final page here, which is the product page, which is the most difficult and the most important one. It's really bad right now. This is like super important for an e-commerce platform, apparently. All right, let's go ahead and fix that one too. So here, I have this product page. Let's start caching just the reusable content here, for example, the product itself, and just add use cache here and mark this as cached. That should be fine. That means we can remove the suspense boundary over here. All right, and this is no longer reloading on every request here, right? For the product details, let's do the same thing. Let's add use cache. Let's mark it as cached. And see if that will also work. It did not. Actually, this is a different error. It's telling me that I'm trying to use dynamic APIs inside of this cached segment. And that is true. I'm using the Save Product button, right? That allowing me to click and toggle the saved state. So what do you think we can do with this? We can use the donut pattern again. Actually, we can also slot in dynamic segments into cache segments. So we're interleaving them just like before, but with cache. So this is pretty cool. Let's go ahead and add the children here, like that. And this will remove the error, and I can just wrap this around this one dynamic segment of my page here, remove the suspense boundary, and add in just a very small bookmark UI for that one dynamic piece of the page. And let's see how that looks now. So notice how almost the entire UI is available, but I have this one small chunk that is dynamic, and that's fine. Everything else is still there. And let's leave the reviews dynamic, because we could keep those fresh. There's still one more error. Let's just quickly tackle that. Again, this is the params. I'm getting help that I need to make a choice, either add a loading fallback or cache this. Let's just use generate static params in this case. Kind of depends on your use case and your data set, but for this case, I'm just going to add a couple pre-rendered, predefined pages, and then just cache the rest after generated by users. And this will remove my error here. So I think I'm actually done with my refactor. Let's go ahead and have a look at the deployed version and see what that looks like. So I just deployed this on Vercel. And remember, I purposely slowed down a lot of data fetches here. And still, when I load this page initially, it's just, everything is just available already, right? The only thing here is just those few dynamic segments, like the discounts and the for you. Same with the browse all of the UI is already available. And for the product itself, it just feels instant, right? And remember again that all of these cache segments will be included with the static shell with partial pre-rendering. And it can be prefetched using the improved prefetching in the new Next.16 client router. So that means that every navigation it just feels so fast, right? All right, to summarize, with cache components, there is no more static versus dynamic. And we don't need to be avoiding dynamic APIs or compromising dynamic content. And we can skip these complex hacks and workarounds using multiple data fetching strategies just for that one this cache hit, as I showed you. So in modern Next.js, dynamic versus static is a scale. And we decide how much static we want in our apps. And as long as we follow certain patterns, we can have one mental model, which is performant, composable, and scalable by default. So let's get back to the slides. And they're here. OK, great. Yeah. So if we're not already impressed by the speed of that, this is the Lighthouse score. So I collected some field data with Vercel Speed Insights. So we have a 100 score on all of the most important pages: the home page, the product page, and the product list, even though they are highly dynamic. So let's just finally summarize the patterns that will ensure scalability and performance in Next.js apps and allow us to take advantage of the latest innovations and get scores like this. So firstly, we can refine our architecture by resolving promises deep in the component tree and fetching data locally inside components using React Cache to do duplicate work. We can avoid excessive prop passing to client components by using context providers combined with React use. Second, we can compose server and client components using the donut pattern to reduce client-side JavaScript, keep a clear separation of concerns, and allow for component reuse. And this pattern will further enable us to cache our composed server components later. And finally, we can cache and pre-render with use cache, either by page, component, or function, to eliminate redundant processing, boost performance and SEO, and let partial pre-rendering statically render these segments of the app. And if our content is truly dynamic, we can suspend it with appropriate loading fallbacks. And remember that all of this is connected, so the better your architecture, the easier it is to compose, and the easier it will be to cache and pre-render with the best results. For example, resolving dynamic APIs deeper in the tree will allow you to create a bigger, partially pre-rendered static shell. And with that, this is the repo of the completed version of the application. There's like so many things that I didn't even show in there that you can check out. And you can scan the QR code to find my socials there alongside the repo if you don't want to take a picture and type it in yourself. So yeah, that's it for me. Thank you, Next.js Conf, for having me here. Thank you.
Holy moly.
Please welcome to the stage Sanity Principal Educator, Simeon Griggs.
Hello, Next.js Conf. Those who are watching online, hello, Internet. And to those in our Sanity Slack, hello, water cooler. I'm here to talk about content operations in the age of AI-generated content. So when it comes to creating content, the scales have been tipped into the favor of people who don't care about wasting your time. When we create content without context, we know these tools don't know your audience. They don't learn, they don't get any better. And AI tools, as they're currently sold, do a really good job of convincing you that you, human, are not good enough to do the thing. You can't write an email on your own. You can't write a blog post on your own. You can't write meeting notes on your own. You can't be human without the help of AI. You're just a sack of meat that needs AI's help. And I don't think this is right. I think AI is awesome, right? It gets a superpower, it's a technology upgrade better than any that I've ever seen in my career. I'm not a doomer on this thing. It's just that I think that you're awesome too. And that's what I want to look at today. I've got a demo I'm going to show in a moment using the AI SDK, Next.js 16, API routes and all of this, along with Sanity. So all of us get to determine what's the future going to look like? Because we've got tools that look like they came and were given to us from the future, right? But we've got them now. So we get to decide what does now look like. And that's in our hands, what we'd like to do with that. So Hollywood's given us visions of the future for years, and we get to choose what do we want now to look like. There's all sorts of different visions of the future. And I know our CTO is very fond of a particular vision of the future that looks something like this. And that's what I think that working with AI can be like, particularly when we're creating content. Right? We don't just have to let the machines take over and completely cede control, but we're still in control. We've still got our hands on the joysticks there. We can take on whatever's greater than us and take it on with absolute confidence. So before we get to the demo, let's just set the table. What's Sanity? Actually, first of all, who am I? I'm Simeon. Hello. I'm an educator at Sanity, and we've been at Next.js Conference for a number of years, which is excellent. Sanity is a content operating system. If you've heard of Sanity, you've probably heard of it as a content management system, and that's fine. If you want to call us that, I've heard people out at the booth today saying, oh, Sanity, they're a CMS. That's fine. But we'll get to unpack why we're a bit more than that soon as well. And as I said, we've been at Next.js Conf now for like the last 5 years, I think. Really been close to this community. We issue a lot of packages, templates, guidance. Our engineers work directly with Vercel's engineers to make sure that you get the very best experience. Sanity's the perfect pair with Next.js for content-driven applications. And some of the things we've said over the journeys is we talk about structured content. So what's structured content? That means you want to store things based on what they are, not what they look like. And you might be saying, but Simeon, one of the great things about AI is that it can take just unstructured junk content and turn it into structured content. And that's true, but you'll be able to do much more when you are creating a source of truth that is structured content. And actually means there's never been a better time to migrate into a system that values structured content. We've also talked about content as data for the longest time, and it's really cool to see as we've got all these new tools and the language has evolved over the journey that I suppose we could probably change some of this language and it still means the same thing. I think these days we'd say content is context. So what your company knows and what you store in your data set, that's all context that can help the AI generation process. So that's how we sort of set ourselves a little bit apart. But what's a CMS for? What's a content management system for? This has typically been the experience, if you work with CMSs in the past, is that an author or a content operator, somebody on a content team, they use a CMS and they create a page. And that individual person makes individual pages, and when they need to modify those individual pages, they go and make those changes. And there's this one-to-one relationship between what it looks like on the website and this individual that works on that page. And that doesn't scale. And that's what I want to talk about today, is the ability to scale with AI tools without producing junk. So one author uses one page. And that's the experience that us developers in the room have given content creators for the longest time, right?
But that's not how you and I work. You and I work more like this. So as developers, we work with source code, and we put that through a compiler, and then we serve that built content to the page, those built scripts to the page. And so we only ever concern ourselves with the source code. So that's how we work. That's not how the experience we've given to content teams. And I know because we're all very good developers and we're all getting on board with AI tools and we're all trying to impress everybody, we're moving towards a future of spec-driven development, aren't we? Aren't we? And this is the future that we're told we can go towards, that if we just keep modifying the spec and we keep modifying the PRDs, then the LLMs will create the response. And we shouldn't need to modify the response, we'll just modify the original spec. And that's the future we're heading towards. But again, you can see it's just one-way traffic. And I think that's an experience that we can give to content creators, is that if we put them in charge of creating the source content, that is what your business knows, that source of truth, those prompts, and put all of those inside of a content operating system, then your authors only ever concern themselves with just generating lots and lots of output. And they don't have to go and click and drag individual blocks and pieces into place. If you're working with a CMS that's still based around pages, well, difficult to imagine that scaling with AI. So developers, you write source code, you and I write source code, so why can't we get our content authors to write source content? It's a future we can get towards. So instead of thinking about a content management system, what if we think about a context management system? And as somebody who writes these slides for a living, I pat myself on the back when I came up with that one. I thought it was pretty good. And then I was immediately told by one of my colleagues that I'm not the first person to say that. So anyway. So what are content operations? I've mentioned those a few times today. It's probably not entirely understood. So content operations, something like this. When you're working with a CMS, it's mostly concerned with this action here. Just you are working in something else and you copy it and you paste it into your CMS, whatever variety that is, and you hit the publish button. And that's kind of the journey of content in a CMS. But we know there's so many things that happen before we get there. There's this whole life cycle of content that happens before you get to the publish button. You are researching, writing, getting approvals, going through tasks and comments, and ideating, all of this thing. There's all this life cycle of events that are happening before you press publish. Those are all content operations. People are involved in those steps. It might not be something that you as a developer get too terribly involved with, but there's a lot of work happening there. And that's what we are largely concerned about. And not only does things happen before you press publish, there's a lot that happens after we press publish as well. So we need to kick off cache invalidation. We need to rebuild the site. We need to redeploy things, syndicate content across all sorts of systems. There's all sorts of things that need to happen in the life cycle after we press publish. And that full breadth of operations there, those are things that people are involved in doing. And that's content operations either side. And while your CMS is probably still just only ever really concerned with that thing in the middle. So sanity is for everything before and after pressing publish. I'm going to say that again for effect. Sanity is for everything before and after pressing publish. So yes, we're a CMS, we've got these pieces as a CMS, but I've got too much ambition to leave it there. So we created a content lake, which is like a real-time multiplayer editing data store, and we knew that we'd need to do more with that. So we built a real-time CDN. We showed that off last year, so a real-time CDN that scales massively for queries and assets. We also knew that we'd need to be able to query JSON, so we built this query language called Grok, a name that's now been co-opted by others, but it's kind of like SQL for JSON. It's an open standard that we shipped. We also ship portable text. It's an open standard for portable text and for block content and rich text. And we ship an editor that's built in React and a serializer for that in a number of different languages. And we knew that once you start building out this content operations infrastructure, you'll need to be able to deploy that as code. So we built blueprints. It's like this infrastructure as code ability to deploy that. We knew we'd need to be able to kick off functions, to perform actions in that after cycle of after you press publish. And we knew that the Sanity Studio alone would not be enough. You need to build multiple applications to be able to do content authoring. So that's where we built the app SDK. And so all of these things together, this is the content operating system, where organizations that know they need to put their content into something where they can extract value from, they put it into a content operating system. We've also sort of shopped this around. I don't think it makes much more sense, but I thought I'd put it in anyway. So hang on, Simeon, I'm getting impatient. I thought this talk was about AI, and I promise I'm getting back to it. So again, if we think back in the history of Sanity's been doing this for a long time, we want humans and robots together to work together, and we always have. So for as long as the content lake concept has been around, we've always had that multiplayer editing capability. It's just that originally we thought that would be like APIs, sending edits to documents for the longest time. We didn't know that so quickly we'd have the ability to work with LLMs. And we do. But now there's this term about keeping a human in the loop, and that seems to like relegate the role of a human into like this innocent bystander role, where the robots are doing all the work and we're just in the loop. We just check in occasionally. And this seems like the wrong paradigm, I think, this human in the loop idea, where we sort of just check in occasionally while the robots create all of this. So like this is the easiest thing to make with AI content. If we just want to generate content at scale, if I say I need 100,000 pages, you can very easily make 100,000 sloppy pages. And we all know AI slop. You know, you've been reading a Twitter thread and it's kind of got that weird smell to it. Like it seemed interesting at first, and then it sort of tails off. It doesn't make any sense anymore, and it's got too many M dashes, and it says it's not just X, it's Y. But you can work out that there's slop, and maybe eventually we get to a point where you can't detect it. But we're not there now. So slop is like context-free. It doesn't say anything in particular about you and your organization, your goals. It doesn't convert because it's just easily dismissed. How many AI-generated images and things have you just scrolled past in your timeline because it's very clear? It's really easy to scale, and that's a problem. If you need to create content-driven applications at scale, this is kind of the easiest thing to do, unfortunately. But the thing to think about, too, is that slop's not new. We've had like human-powered slop for the longest time. I mean, I was walking past my local coffee shop the other day, and there was a picture in the window of like an AI-generated picture of brownies. They got a sale on brownies if anybody's in Whitley Bay soon. And you know, once upon a time, that would have just been clip art or like a stock photo or word art or something. So like we've had context-free bad content for the longest time. It's just now you can generate this at scale. So we've got two problems I want to solve today. So one, authors writing outputs doesn't scale. If you are going to task somebody who is authoring in a CMS to create individual pages, they're not going to create very many because they're time limited. And the other problem is if we just use AI to generate all that content, it doesn't convert. It doesn't help to just generate huge volumes of content if it doesn't help. I don't know if anyone's been tracking the number of times I've said content. I'm going to check this in the transcript afterwards. So anyway, we don't have to pitch this as a binary choice of which end of this graph we're going to be at. Are we going to create either human-created content or AI-created content? Because both ends of this chart have their problems. One's too slow, it won't scale. And the other's too sloppy, it won't convert. But somewhere in the middle, there's this idea that if we keep a human involved, not in the loop, but orchestrating the content creation experience, and we can enhance their skills with AI, that's where we can actually compete at scale and make a great amount of content. And we're sort of back at this analogy again. So the goal is to have a world where one author can use a content management system or a content operating system and write many prompts and create a near infinite amount of pages. And if this sounds like philosophical or farcical or not from the real world, we've got customers who are doing this right now. So like one particular customer uses Sanity. They're a travel tech startup in the UK. They use a system which I'll demonstrate a version of in a moment, where they can generate content for like 50,000 hotels on demand, but it's very specific content specific to them and their audience. And they can personalize that. So this is actually happening now. So once upon a time where individual authors would have had to have written individual documents, they can instead now generate content at massive scale, which they approve the quality of. And so their content management system looks something like this, which I included this slide, but I'll show this in a moment in my demo. So if we can go over to the screen now, I'll show you what this looks like. All right. I'll give it a refresh for good luck. I've got a notification here. We introduced a new feature today that's not part of this slide. If you'd like to go and see our booth about the Sanity Content Agent, someone will show you a demo of that. That's very useful. So what I've got here is a Next.js 16 application on the left-hand side. This is in our presentation mode. And on the right-hand side, that's the Sanity Studio. It's that main content editing interface. And what we've got here is just an individual page for a particular location. And sort of the sloppy version of creating content here is our description's currently blank. And so what if we need to generate a description on demand? Well, I've created a API route using the AI SDK, and it's just going to create a simple description. If we go ahead and look at the prompt for that, it just looks like this. Only return plain text, write a description for this location. So this is like the most basic version of this prompt, but all the prompt is kept on my side in the code here. And so what do we get? We get sort of that very generic, unhelpful, boring, sloppy version of this content. This isn't helpful. We've generated text, yes, but this isn't going to help anybody. So sort of the whole intention and the value of this talk that I'm mentioning today is the idea that what if we can put the authors themselves, the content operators themselves, in control of what we create? By the way, we've got some AI tooling in Sanity, like built-in tools that we could have used here, but it's Vercel Next.js conference. I wanted to use the platform, so to speak. So what I've built here is a custom tool. If I stop right-clicking there, where I can generate a description using a few prompts. And all of these documents are documents stored inside of my Sanity data set. So it's not news to anybody in this room to like write prompts and get better content, right? The difference is here that if I build all those prompts into the system where my content operators work, then they are in control of the experience of what comes back. So I don't have to get called in every time that content being generated isn't very good. They're able to modify the prompt. So what if we go and select all of these prompt documents and then we can add other contextual information, like do we have offers at the moment for this particular location? And then we can create really specific content. And where all these prompts coming from, I'll jump over to here. We can see that these prompts are being stored in the studio, and this is literally what the Love Holidays team are doing there. And while I'm going to generate this content here one by one, I'm told that the team there have been able to refine their prompts to the degree where they can now initiate actions like this en masse and just about trust that what they're going to get back is exactly what they need. And so they're no longer really needing to review content. They can pretty much trust that what they're getting back now, because the prompts have been so well refined, is exactly what they'll need. So if we go ahead and include all these other things here, I'm going to generate that description again. And if we have a look at that API route, we can see, I've pulled in these prompt documents, which are being worked on by those content authors. I can pull in any current offers. So if there's offers running in this location at the moment, we'll include that into the text of the article. And so this is an idea of how we can make sure that we've got not only relevant content to the tone of voice and everything of our customers here, but also if we have promotions, we can make sure we can personalize this offer, and we'd be able to take this even further, localization, personalization based on the customer profile, all of this. So what we get now is a very different version of the content. So that last one was just like one paragraph there, a very generalized content, where here we can see the very first sentence now mentions one of those offers. The content's much shorter, it's to the point, and it follows those prompts much closer than it did before. So again, this is just an example of creating one page on demand here, but we could imagine how we'd be able to then put bulk tools into the hands of content creators to generate that content en masse. And so that's just a really basic demo of using AI SDK. But again, sort of the value of what we're trying to demonstrate here is that if we put our authors in charge of building out a content model that describes what our business knows and how our business talks, then they no longer have to worry about creating individual pages. And you can go from creating a page a day to creating tens of thousands of pages of high quality content on demand. So if you'd like to know anything more about what I've shown today, go and have a look at sanity.io/next. And if you're here at Next.js Conf, make sure you come and swing by the booth as well, and we can show you more demos of this and more of the AI tooling that we've got available for content operations. And so that's it.
Please welcome to the stage Vercel software engineer, Reese Sullivan.
Great, thank you. Hi, so I'm Reese. I'm an engineer on the domains team at Vercel, and I wanted to really kind of go over use cache, what it unlocks, kind of how we got here, and why I'm excited about it. So going over the agenda, we're going to look at kind of the evolution of use cache in Next.js, the functionality that it unlocks, and then how you can kind of use cache to make it hide away into the background and more of an implementation detail. So from the talk title, what is reactive state? So it's kind of this concept of when you make a change, all of the people should see that change reflected without having to kind of encounter stale data. It's a common problem that kind of many apps that you have use. For example, how many times have you flipped a toggle on one browser tab, but the other browser tab that you have open doesn't reflect the changes that you just made? The scenario here kind of highlights it, but it might not be super common where you have two tabs open at the same time. But you can imagine, your teammates updating state at the same time, and the page doesn't reflect that state. Same thing, we're kind of leaving a comment and then not seeing that reflected. On the front end, we have a lot of tools to solve this problem. We have the ability to listen to changes to data over WebSockets or SSE, and it's pretty fixable in that you set up a subscription on the client to the data that's changing and then refresh the state based on that. And we've seen more apps kind of adopt this over time. For example, one of our products, V0, when you send a message, it updates in real time across the browser clients. It's a fair bit easier to kind of ship updates to spa-like apps, as you can start a listener on the client. But whereas when you're server-side rendering your pages in either a distributed or a serverless setup, you don't have that persistent client to kind of start a connection. And along with that, you might be managing multiple cache locations, whether that be your data cache or your CDN cache. It's a lot of state that you have to track. So kind of reactive state. And now kind of my background, a lot of the experience that I have is building really fast performing, high scale sites for Next.js. In the past few years, I've helped build Next.Faster, which is a demo e-commerce site with over 1 million products and instant page navigations. Answer Overflow, a Next.js app that has over 2 million pages, and then Vercel Domains, which is a real-time search for domain names. And so kind of what do all of these have in common? Well, they all make really heavy use of caching. And the reason that they use caching so extensively is to get data close to the user. And so if caching is so great, then why aren't all the sites fast, and why don't we just cache everything so it loads instantly? Well, you have to account for all of the places the cache data is used in order to revalidate them, and also make sure that that data isn't stale. And so with Next.Faster and Answer Overflow, while both of them are great at serving lots of pages, they're not super reactive to the changes that are made. And so kind of looking at why that is and how caching has evolved with the Next.js, in Next.js, starting with the pages router, you had two options for caching. The first one was either manually writing data to Redis or some similar data store. This would be what you would use if you wanted to cache the results of a call in between kind of deployments or keep it in memory. The other one would be writing pages to ISR cache, and this would be done by adding get dynamic props or get static props, along with specifying a revalidate time. And you'd use that when you wanted to kind of serve pages from the edge cache or a CDN cache. That's how you cache data from the pages router, but then invalidation was a much more painful story. You'd have to call a route handler and then figure out all of the places your data was used, and then call revalidate for every single path that that data was used on. This meant you'd be doing a bunch of manual work to track all of the places that your data was being used, and then also calling revalidate. And so why did you have to call revalidate so many times? Well, from the perspective of the framework, in the pages router, a route mapped to a rendered page, but the framework didn't know what data went into rendering that page. In this case, post/id calls get content, get views, get users, but the framework doesn't know about that mapping and that data that the page depends on. All it knows is that the route maps to the rendered page. So then came along App Router, and with App Router, it introduced the concept of your framework understanding caching and providing primitives for you to use to cache data. It started with the kind of awkward teenage years of unstable cache and then an option for fetch caching. But that API was pretty clunky to use and fairly limited in its ability. For example, you weren't able to use the result of a call with unstable cache to set cache tags based on it. It then pretty quickly evolved to use cache, which is a really nice interface which lets you cache both React components and data, and it's the shared interface for both. And so when kind of use cache was introduced and then the other caching primitives that Next.js has, a question you might ask yourself is, why is it introducing these primitives? Why does my framework care about how I cache data? And that kind of comes back to fine-grained reactivity and caching of data. So for a given route, it knows exactly what data makes up that route, and then the framework is able to respond with either like a cache tag header that then a kind of downstream cache is able to use to do granular revalidation of changes. And so kind of from this diagram, we can see that for the path post ID, it calls get content, get views, get users again in order to render the page. But in this case, the page actually knows about the fact that those functions went into it. And not only does it know that those functions being called to render that page, through cache tags, you're able to provide metadata about the returned results. And so it knows not only that the functions are called on that page, but also the returned data is that page is dependent on specific data. And so kind of when you contrast that to pages router for doing revalidation, it's just one call to revalidate all of the places that data is used on. And not only is it just that one call to revalidate the pages, also if you're storing data in like a data cache, like for example, how you would use to store it in Redis, it's the same revalidate tag call to that location. And so because the framework handles the caching and tracking for you, it's able to handle this for you, rather than you having to do all this manual work to specify revalidate locations. And so if you kind of look at the APIs here of the traditional Redis cache to unstable cache to finally use cache, the DX wins are really clear on use cache. You don't have to add conditional logic to caching, to your function flow. And not only is it a nicer API for handling caching, it's unlocking more functionality while providing a nicer API that wasn't possible before in Pages Router. So that's kind of the background on why use cache was introduced and what it unlocks. But how does it look like in practice, and kind of how am I thinking about building with it? Here's where things I think get really cool, is you're able to set up your code base in a way where you very rarely think about use cache. Instead, you're able to just write your code as normal, and then you can keep your content fresh automatically by subscribing to changes. This is accomplished by localizing use cache to the places data is fetched, calling revalidate tag on data change, and then using narrow tags to just revalidate the data that changes. We're going to go over two examples. The first one's using Convex, which is a database, and the next one is using a CMS. So first, starting with Convex. For those of you unfamiliar with Convex, it's a database that's excellent at tracking the changes to your data and broadcasting to subscribers when data changes. The kind of setup that I have for it is I created a wrapper function that starts a subscription on query changes, and then when a change comes into that specific query, it calls a webhook to revalidate that tag. It's a small amount of one-time setup, and the benefit is I'm able to reuse that all throughout my application to have up-to-date server-side rendered content. Let's dive into the code to see how this looks. So everywhere that I need to fetch data in my application, this is what it looks like. I pass the name of the function and the args the wrapper function, get the result, and can use it as normal. I think what I love so much about this is that it's just kind of the standard, like, await data, use the result. But with kind of putting use cache in the background and an implementation of this function, it's never stale, it's granularly cached, and you're getting the benefits of server-side rendering. And all you have to do is call your query function. So kind of a look at what that function looks like. It's got a few parts, breaking them down. The first part is kind of the use cache, specifying that that function is going to be, the results of it can be cached. Then it creates a key, which is the hash of the function name and the args, and that's what we're going to be using to revalidate later on. Then it calls convex to get the results of the database query. This is kind of your standard database lookup. And then after that, it sets up a subscriber to listen to the changes. For the purpose of this demo, the subscriber is one that I had to set up manually. There's like a world where providers kind of provide more APIs for exposing cache keys and things to cache on with callbacks. And then finally, it sets a cache tag, and that's how we're able to revalidate it. And then we're using a cache life of weeks, as we'll be handling the kind of revalidation of this data. And then finally, this is the callback function that gets called on data change. It's pretty simple. It's pretty straightforward, where convex gives us that key back, which is the hash of the function name and the arguments passed to it. And we pass that directly to revalidate tag in order to revalidate it on a notification of data change. So looking at kind of a demo of what this looks like in practice. This is without the using use cache and subscribing to data changes. You can see that when you add a message and then do a refresh, you can see that there's kind of a flash of incorrect content. And so what's happening here is the server-side page is rendering, it's showing the stale content. The client is then doing a fetch, and that's rendering the up-to-date content from the server. But there's a mismatch between them. And this is because the server-side rendered content is out of sync. So then kind of like looking at the other setup, so this is calling revalidate on data change. And so when I add a message and do a refresh, you can see that there's no layout shift, there's no flash of stale content. It's just revalidating the changes. And so the kind of next example I wanted to walk through is hooking it up to a CMS. And so it's another example where you might have like a CMS and it's got author information, and you have a function to get that author information. This function might be called on an overview of a list of posts, an individual blog page, or an author page. And it's the same thing, where you provide a data function to get the data, you specify use cache, and then you return the results. And then the next step is making the data live. Most CMSs provide webhooks on data change, so we're subscribing to a webhook from our CMS, and then if it's a change to the author details, we revalidate that tag. This could also be called from your database write path. In this case, it's showing how to integrate with an external service. So coming back to this example before of revalidating many pages, I think it really shows the kind of value in use cache and the Next.js caching system. With one revalidate call, you're able to invalidate all of the locations that data is used and the remote cache. I'm slightly glossing over for these demos the context of how revalidate tag gets called, just because it varies a fair amount based on your data access and mutation patterns. The example of a CMS provider and integrating with your database should be both pretty common patterns that you can build from. The focus here is more so on what use cache and revalidate tag are able to unlock in keeping your routes rendering fresh data without having to set arbitrary expiration times. The last thing I want to do was run through some kind of additional scenarios that use cache that you might run into with use cache to give you more items to add to your tool belt. Ideally, you have this beautiful caching setup with granular validation, but sometimes it's helpful to have fallback options. So here's an example of setting a cache tag to enterprise. This would be helpful if you needed to invalidate all enterprise customers' data, for example. Another one would be making sure that all data fetches related to a specific customer have the same ID, so that way if you need to invalidate just that customer's data, you can do one call to invalidate it everywhere. Another kind of basic example, but use cache makes it really easy to have different cache lives depending on how old your data is. So in this case, if my data is not changing often, I might want to use weeks as the cache time instead of hours, and I just specify that in cache life. Next.js also supports bringing your own cache handler. So if you kind of want more control over how caching happens in your app, you're able to implement your own. And then lastly, I wanted to call out kind of a difference between update tag and revalidate tag. So update tag gets called from server actions, and it allows you to ensure the next request will be up-to-date content. So the difference between update tag and revalidate tag is revalidate tag does background revalidation. And so it's kind of still while revalidate, it serves still content for the first request, revalidates it, and then returns the up-to-date content. Update tag forces kind of the next request to serve fresh, up-to-date data. So that's kind of the overview of kind of why use cache exists, what it unlocks, and then how revalidate tag allows you to make pages live. If you're interested to get the source code for the convex demo that kind of shows how I'd implement this in a more production app, here's a QR code you can scan to get those resources. Well, thank you so much.
Please welcome to the stage Databricks developer advocate, Ryan Vogel.
I will not be talking about cache components today. So this is AI. All right. Please build me a $1 million B2B SaaS using Next.js and NeonDB. No mistakes, please. Send it, and that's the talk. Thank you. No. So we've all seen these vibe coders, though, where they are just shipping unsafe production code, and it's just breaking data, and they're spending thousands and thousands of dollars on like exposed API keys. But at the same time, it begs the question, can you like reliably use AI in your daily workflow? Yes, you can. My name is Ryan Vogel. As he said, I am a DevRel for Databricks, and I've shipped a ton of personal and professional projects, with many having users over thousands and thousands of users, and I've used billions of tokens on Cursor, which is probably the only accolade I need. Anyways, we're going to be focusing on a side project of mine called Inbound. Inbound is my email infrastructure project, and I've personally shipped over 500 commits in the past 6 months. The average bug is fixed and deployed within 10 to 20 minutes because I'm using my agents. So let's look at the Inbound progress. A little bit more background context. Inbound is an email service that allows you to send, receive, reply in threads, making it easy for AI agents to sort of manage and work with email. This is the landing page 4 months ago. This is it now. That just looks so much more of a legit product if you would tell me. I would believe that. I wouldn't even believe that. That looks like a scam. Anyways, I've done a ton of great stuff with AI, and I've learned how to use it incredibly well. I've been using it for almost 2 years. So let's talk about the important part of treating AI as a teammate. AI isn't here to replace you, but it's your teammate. But people badly prompt an agent, like we'll jump into, where they're like, please fix this, or something like that, and it doesn't fix it. You've got to break down what you want in your head, like the problem, like you would diagnose it yourself, and give that to the agent. So this is the email flow page in Inbound, and it worked. It is aggregating a ton of data from a bunch of different data sources. The outbound emails table, the inbound email table, all the scheduled stuff. But it was slow. It took like 3 seconds to load like a week ago. And it would work, but why can it be this slow? We can't have it be like that. Now, I could have manually investigated this and looked into it and been like, all right, let's dive into the code. Let's look into the drizzle stuff and the SQL queries. Where can I optimize this? But why would I do that if I have an AI assistant to help me? So I opened up Cursor and just opened up my prompt and said, can you fix this, please? I don't need grammar. AI can understand me, right? And yeah, it didn't really fix anything. There's no scope. There's no context. There's no end goal. Could any of you, if I gave this prompt to you, would any of you know what to do? No, there's nothing to do. This is a C tier prompt. All right, let's upgrade. We'll go from C tier to B tier. All right, I'll give you a second to read this. It's a little bit of a better prompt. It's an upgrade because we're having more refined scope. It gives the agent a better mental picture of what we're actually working with. We have some end goals kind of set. But this is the prompt that gets you the dreaded, let me generate a README file for this. That way we can just put everything together and put it all together. And no, we don't want README files generated and markdown stuff. So we'll upgrade again. A tier prompt. This is probably the prompt that I use every single day. If you read it, you'll notice that it's basically the exact same prompt that I had on the other one. But there's one important feature: context. This references the page.tsx file. It references the drizzle schema. It references my hooks folder. All are important data attributes that would go into actually compiling the data for this page. Now, what if we could take this a step further? I know, that's crazy, right? It's crazy to think how we could take this a step further. What if we could let the AI agent deal and work with some of our data, but not have to worry about that affecting our production instance? Enter Neon branches. I love Neon branches. It's probably the favorite part about Neon that it's amazing. So imagine this. We've got our main branch right there. And I want to give the agent access to this, so that way I can let it kind of branch off, try some indexes, and optimize queries, and maybe drop some tables or stuff like that to check optimizations, to see if maybe I'm just pushing something really, really badly. And let's say it just does the typical, you know what, I think we can make this faster by dropping all the rows, typical AI fashion. Now, in a traditional production database, I would be like, oh no, that's not good. There's all my production data. Yikes. But not with Neon. It's a branch, which means that if it deleted all the data on that branch, it doesn't matter. I can just reprune that branch or reset that branch from main, and I would just have a fully functional branch working again. Now, let's take this, pair it with our ATR prompt, and we get this. This is the actual output I got when I was running this a couple weeks ago. And if you look at it, we pair them together, and it gives, like, it was this, it gave a little, absolutely, let's get started on this. And then it gave it this. And text body, HTML body, attachments, and some other stuff. Those are massive fields in the database that I'm pulling from, and that was slowing down the page extremely much. It was like so much slower than it should have been. And I was able to just quickly implement it and fix it, and it was able to be working again. Now, the important part is I worked with the agent on this. I didn't just one-shot it. If you don't know what one-shotting means, it basically means opening up an AI agent like prompt window with the intent to complete it in one step. Because everyone wants to complete it in one step, but seriously, how many of you have told like a coworker, hey, can you fix this? And they've done it in one step. I don't think that's ever happened. So you got to treat AI in the same way. So let's jump into, we know how to like prompt the AI agent a little bit better now, but now we got to worry about threading. So AI provides this unique opportunity to stop a conversation mid-generation, like it's mid-generation, and then go back to the previous prompt and edit. Imagine if you could do that in real life with like talking to someone. That'd be amazing. I would love that. So this is really, really a unique opportunity because it allows you to compact data a lot easier than what we see over here on the right. So if I were to have an initial prompt like this, and then it didn't generate exactly what I wanted, I would then revise it and say, actually, don't modify that file. Go and modify this file. And then I would do it again. That's like 3 times more tokens that I'm using when I could just pause the conversation, go to the original prompt, and say, don't touch the hooks folder, or do touch this folder, or anything like that. You just got to try to compact as much data as possible, because as you'll learn today, context management is key. But this means that you've got to be active in the conversation, which brings me to my next point. You can't just sit back and start your agent and go sip a cup of coffee while you're doing your laundry. When I send a chat, I read the output intently, almost as if like I'm quizzing it. And thankfully, a lot of agents nowadays have their reasoning and their thinking patterns exposed, so you can actually see what it's kind of thinking and working through. And if I see something where I'm like, hey, you shouldn't be thinking that, I stop the model, revise it, and iterate. Now, the 2 main models that I use are ChatGPT, or not ChatGPT, GPT-5 and Claude 4.5 Sonnet. And they're like 2 different brothers, always trying to impress you with their new features and everything like that. But you've got to understand that they're not the same. They do have different personalities that you can pick up on and understand. So, GPT-5, we'll jump into this. GPT-5 is the representation of the measure twice, cut once ideology. You will give it a prompt, and it will just, let me look at this file, and this file, okay, on this file, I could write, nope, I'm not gonna write. I'm gonna look at this file. Let me do some grepping. Let me do some of this. It just does a ton of research. But then when it does edit something, it is extremely precise. But my favorite part about GPT-5 is it's incredible at design. So look at this. This is actually real. This is a Figma of the inbound dashboard. It's the domains page where you can see all the domains that you've added. This is Figma. I used GPT-5 for about an hour and a half with the Figma MCP server, and I created this. This is live. In an hour and a half with the Figma MCP server. I'm not a designer. That's my girlfriend. I am not the designer. That's pretty impressive, right? Let's show the Figma again. And then the live dashboard. That is pretty much nearly accurate. It's crazy that you can do this nowadays, because like 4 or 5 years ago, you wouldn't even fathom to begin with this. It's just, wow. All right, let's jump to the other brother, Claude. Oh, Claude. It's always better at backend, but it just loves to start editing files right away. It's like, all right, let's edit this, and test this, and run lints on this. And no, No need. But that's where you got to learn the model personalities. That's where you got to learn how they work. You got to know that GPT-5 does a lot of research first, but Claude does a lot of editing first. It's very smart, but it can also be very confidently wrong. So when you're doing stuff that it's great at, like summarizing and needle in the haystack recovery, you got to be able to make sure that you can verify that with a third party to make sure that you're not exactly just taking in hallucinated data. So another important part is you got to treat AI as a trusted teammate. And I've got a great story for this that I love to say. So I have a Tesla Model 3. It's got the full self-driving in it. I drive it every day, and I try to use full self-driving as much as I can. And obviously, since I've been using it every single day, I know how the full self-driving model works. I know that it brakes late. I know that it's very aggressive when it's turning. I'm from Florida, so everyone's got to be aggressive. But my girlfriend, on the other hand, doesn't. So when she gets in the car and she rides with me, rightfully so, she sees that we're not braking and is like, oh, no. But it makes sense because I interact with that model every single day, where she maybe interacts with it like once a week. Same thing applies to AI. You got to learn how to work with the models so that way you can learn their strengths and weaknesses. So now that we have trust with our AI teammate, we can now go into context. So context is the memory that you and the AI curate over a conversation, whether that be messages, tool calls, and files. If you think about it like a haystack, and every single piece of message or like tool call or anything like that is a piece of hay in the haystack, it's a lot easier to visualize. But if you don't regulate it correctly, it can lead to a bunch of irrelevant files, data, and more in your chat history. So it's a lot easier to manage and pick out stuff in this haystack than this haystack, wouldn't you say? So Cursor actually launched a really cool feature for this, where it shows a usage indicator, and I keep my context below 20 to 30% on all models, like on average. And if I'm like working on like a really hard bug fix, I let it go up to 50. If it's above 50%, I've seen on average, it just performs worse. More hallucinations, more this, absolutely, all right, oh, I was completely wrong. It just doesn't work. So, for example, in Inbound, got another great example, is threading. If you've ever worked with email threading and sort of that type of stuff outside of like a Gmail, Outlook, or something like that, you know it's a little bit hard. And I was working on a feature for Inbound that makes it easier for agents to use and read and summarize from threads. And I was building it on top of AWS SES, and it was late, and I got stuck. So I opened up Google, like the good old days, and I found this great Stack Overflow article. It's a savior, right? And it was a great answer that basically solved my problem. Now, most coding agents and coding platforms allow you to just like copy the link of a website, paste it in, and yeah, you got your answer, right? You think you should be good? No, don't do that. Here's why. So I built another project called Preview Down, and this is actually live, so it's not just for the thing. You can go to it right now. And I made it so that way it can show how many tokens a website would use if you paste it into an AI agent chat. So obviously, I took that Stack Overflow article, picked it up, threw it in. 7,000 tokens? That answer was like 2 paragraphs. Now, this may not seem like a lot, but it can build up quickly if you have 6 or 7 other different links. This is just not needed, and there's a better way to do this. So what I do is I go into a prompt like this. I give it a little bit of back context. I say, hey, looks like according to some research, we just need the references and reply to header based on this Stack Overflow answer, and then I paste those 2 paragraphs. That is only 131 tokens, which means that we saved 98%. That's a 98% smaller prompt with the same meaning and answer. All right, so this is great. We know how to use AI right. We know how to manage our context and our threads and everything like that. But how does Next.js and open source kind of lead into this? So personally, starting off with Next.js, Next.js is great for AI because it has massive public code exposure. There's a ton of open source repositories on GitHub and other sites that are overlapping in the LLM training data, so AI knows what Next.js is and how to use it. Additionally, it's a very standardized framework, especially with App Router and Pages Router, and there's also additional massive overlap in the training data. So this is an example of another great open source Next.js repository called Dub. And I was working on a feature in Inbound for Dub. If you're not familiar with what Dub is, it's essentially link click tracking and all that other stuff. And I wanted so that way people in Inbound could have link tracking and click tracking directly in email, but linked to their Dub account. So that way they could have everything from a centralized dashboard. Now, I was working on something and trying to get the OAuth config to work, and it was late. I just didn't have the bandwidth to do it, and it just wasn't working. And I got my 9th error of the night, and I'm just like, oh, I can't do this anymore. So what I did was I went and grabbed the GitHub repository for Dub, brought it into Cursor, tagged it, and basically said, hey, can you figure out what's wrong? I don't know what's going on. Now, no. Am I saying anything about Next.js in this? I don't think I am. No, I'm not. I'm not saying anything about Next.js in this, which is right, because AI knows Next.js. It's basically what it's best at. So it understood the problem, and it was able to fix it within a matter of minutes. So got another great example. Remember Preview Down? So that idea came to me while I was writing this talk, because I was like, I'm interested. How many tokens am I actually using up? And I saw that OpenCode, which is an open source CLI tool that basically is like a cursor, but inside of your terminal. And I knew that it had a web search tool. And I was like, hey, I wonder if I could just grab that web search tool and then put it into a website and just make it work. So that's what I did. And I'm not even joking, I cloned the open source repository onto my computer. Then I installed OpenCode. This is OpenCode. I prompted OpenCode to find out what library is used to convert HTML to Markdown, all within itself. It seems like some Inception thing. And this is another thing where I'm using my context of being a developer to know that, OK, I know how to get HTML from a website. I don't need the AI for that. But I do need to know how to reliably convert HTML into Markdown, which the LLMs ingest. So I did that, and it's a very simple prompt if you read it, and it's just I need you to look inside this project to see what library is used to convert from HTML to Markdown. It should be inside the web search function. Another developer thing. I know it's inside of a web search tool call or something like that, just to help the greps a little bit. OpenCode found it in 2 minutes, and here's where it gets really crazy. It was able to identify that it was turned down, and it found some references of how it was actually used. But then I took, in the same session, I said, hey, I want to create, and I essentially described the Preview Down website. I said, hey, I want to create this website where you can paste in a URL and just have it output the context and the token usage and everything like that, generate a prompt so that I can create it. So it would basically build it out for me. But I don't want to build anything. Come on, it's the age of AI. I'm not going to build anything. So I took that generated prompt into V0, and it one-shotted it. The live site that you see now is the one-shot. Obviously, it's very simple, but still, the live site on previewdown.com is the live site that was generated by V0. That whole thing took 10 minutes from idea to deployment on Vercel. Right? I mean, that's crazy. I genuinely can't even conceive. It reminds me back in the days when I was doing FileZilla with PHP and just double-clicking, waiting for it to upload. I love this world so much better. So anyways, let's wrap it up. You got to treat AI as your teammate. You got to trust it. Why would you ever want to work with a coworker that you don't trust? You got to trust your coworkers. Now, do you let them do whatever they want? No. Do not give them access to your terminal, especially. Always run that in a sandbox. Trust me, I know. Then you gotta know the personalities. The different models, I just highlighted the OpenAI and Anthropic ones, but there's lots of different models, and try out those different models. Maybe you'll find one that you'd like to work with better. The most smartest model is not always the best model for the job. Play around with them, especially in Cursor, where it allows you to have access to those models really easily. It's a perfect opportunity to try out a Grok code or something like that. And then obviously, leverage open source for AI projects or any other project, because even if your project isn't licensed to open source, it still can be extremely helpful to developers, like in that Dub example, that are trying to figure something out, and they're like, I just wish I could see the inside of the code base. And I could, so it was great. Now, especially leverage projects that are open source on Next.js. But wait, don't open up Google or ChatGPT or any other AI search and say open source Next.js repositories. Look no further than Inbound. You can check out the full Next.js inbound repository at git.new/inbound. And if you want to try out the best way to interact with email and agents in the future, inbound.new. And if You thought I did a good job for my first ever conference talk, give it a star. But don't if I didn't do a good job. But thank you.
Please welcome to the stage Vercel software engineer, Luke Sandberg.
Should have practiced more with this. Okay, thank you, everyone. Hello. My name is Luke Sandberg. I'm a software engineer at Vercel working on TurboPack. So I've been at Vercel for about 6 months, which has given me just enough time to come up here on stage and tell you about all the great work I did not do. Prior to my time at Vercel, I was at Google, where I got to work on our internal web tool chains and do weird things like build a TSX to Java bytecode compiler and work on the Clojure compiler. So when I arrived at Vercel, it was actually kind of like stepping on to another planet. Like everything was different. And I was pretty surprised by all the things we did on the team and the goals we had. So today I'm going to share a few of the design choices we made in TurboPack and how I think they will let us continue to build on the fantastic performance we already have. So to help motivate that, this is our overall design goal. So from this, you can immediately infer that we probably made some hard choices. So like, what about cold builds? Those are important, but one of our ideas is you shouldn't be experiencing them at all. And that's what this talk is going to focus on. In the keynote, you heard a little bit about how we leverage incrementality, and I'm not entirely sure that that's a word, but that's what we're calling it, to improve bundling performance. The key idea we have for incrementality is about caching. We want to make every single thing the bundler does cacheable so that whenever you make a change, we only have to redo work related to that change. Or maybe to put it another way, the cost of your build should really scale with the size or complexity of your change rather than the size or complexity of your application. And this is how we can make sure that TurboPack will continue to give developers good performance no matter how many icon libraries you import. So to help understand and motivate that idea, let's imagine the world's simplest bundler, which maybe looks like this. So here's our baby bundler, and this is maybe a little bit too much code to put on a slide, but it's going to get worse. So here we parse every entry point, we follow their imports, resolve their references recursively throughout the application to find everything you depend on. Then at the end, we just simply collect everything each entry point depends on and plop it into an output file. So hooray, we have a baby bundler. So obviously this is naive, but if we think about it from an incremental perspective, no part of this is incremental. So we definitely will, parse certain files multiple times, maybe depending on how many times you import them. That's terrible. We'll definitely resolve the React import like hundreds or thousands of times. Ouch. So if we want this to be at least a little bit more incremental, we need to find a way to avoid redundant work. So let's add a cache. So you might imagine this is our parse function. It's pretty simple, and it's probably kind of the workhorse of our bundler. Very simple. We read the file contents, hand them off to SWC to give us an AST. So let's add a cache. OK, so this is clearly a nice, simple win. But I'm sure some of you have written caching code before. Maybe there's some problems here. Like, what if the file changes? This is clearly something we care about. And what if the file isn't really a file, but it's 3 symlinks in a trench coat? A lot of package managers will organize dependencies like that. And we're using the file name as a cache key. Is that enough? Like, we're bundling for the client and the server. Same files end up in both. Does that work? we're also storing the AST and returning it. So now we have to worry about mutations. So, and then finally, isn't this a really naive way to parse? I know that everyone has massive configurations for their for the compiler. Like some of that has to get in here. So yeah, these are all great feedback. And this is a very naive approach. And to that, of course, I would say, yeah, this will not work. So what do we do about fixing these problems? Please fix and make no mistakes. So, OK. So maybe this is a little bit better. You can see here that we have some transforms. We need to do customized things to each file, like maybe down leveling or implement use cache. We also have some configuration. And so, of course, we need to include that in our key for our cache. But maybe right away you're suspicious. Is this correct? Is it actually enough to identify a transform based on the name? I don't know. Maybe that has some complicated configuration all of its own. And OK, and is this to.json value going to actually capture everything we care about? Will the developers maintain it? How big will these cache keys be? How many copies of the config will we have? OK. So I've actually personally seen code exactly like this, and I find it next to impossible to reason about. OK. We also tried to fix this other problem around invalidations. So we added a callback API to read file. This is great. So if the file changes, we can just nuke it from the cache. So we won't keep serving stale contents. OK, but this is actually pretty naive, because sure, we need to nuke our cache, but our caller also needs to know that they need to get a new copy. So OK, so let's start threading callbacks. OK, we did it. We threaded callbacks up through the stack. You can see here that we allow our caller to subscribe to changes. We can just rerun the entire bundle if anything changes. And if a file changes, we call it. Great. We have a reactive bundler. But this is still hardly incremental. So if a file changes, we need to walk all the modules again and produce all the output files. So we saved a bunch of work by having our parse cache, but this isn't really enough. And then finally, there's all this other redundant work. We definitely want to cache the imports. We might find a file a bunch of times, and we keep needing its imports, so we want to put a cache there. And resolve results are actually pretty complicated, so we should definitely cache that so we can reuse the work we did resolving React. OK, now we have another problem. Your resolve results change when you update dependencies or add new files. So we need another callback there. And we definitely also want to cache the logic to produce outputs, because you think about it, in an HMR session, you're editing one part of the application. So why are we rewriting all the outputs every time? And also, you might delete an output file, so we should probably listen to changes there too. OK, so maybe we solve all those things, but we still have this problem, which is every time anything changes, we start from scratch. So kind of the whole control flow of this function doesn't work, because if a single file changes, we'd really kind of want to jump into the middle of that for loop. And then finally, our API to our caller is also hopelessly naive. They probably actually want to know which files changed so they can push updates to the client. So yeah. So this approach doesn't really work. And even if we somehow did thread all the callbacks in all these places, do you think you could actually maintain this code? Do you think you could add a new feature to it? I don't. I think this would just crash and burn. And to that, I would say, yeah. So once again, what should we do? Just like when you're chatting with an LLM, you actually first need to know what you want. And then you have to be extremely clear about it. So what do we even want? So we considered a lot of different approaches, and many people on the team actually had a lot of experience working on bundlers. So we came up with these kind of rough requirements. So we definitely want to be able to cache every expensive operation in the bundler. And it should be really easy to do this. Like, you shouldn't get 15 comments on your code review every time you add a new cache. And then I don't actually really trust developers to write correct cache keys or track inputs or track dependencies by hand. So we should handle it. We should definitely make this foolproof. Next, we need to handle changing inputs. This is like a big idea in HMR, but even across sessions. So mostly this is going to be files, but this could also be things like config settings. And with the file system cache, it actually ends up being things like environment variables too. So we want to be reactive. We want to be able to recompute things as soon as anything changes. And we don't want to thread callbacks everywhere. Finally, we just need to take advantage of modern architectures and be multi-threaded and just generally fast. So maybe you're looking at this set of requirements, and some of you are thinking, what does this have to do with a bundler? And to that, I would say, of course, my management team is in the room, so we don't really need to talk about that. But really, I'm guessing a lot of you jumped to the much more obvious conclusion. This sounds a lot like signals. And yeah, I am describing a system that's like signals. It's a way to compose computations, track dependencies with some amount of automatic memoization. And I should note that we drew inspiration from all sorts of systems, especially the Rust compiler and a system called Salsa. And there's even an academic literature on these concepts called adaptons, if you're interested. OK, so let's take a look at let's see what this looks like in practice. And then we're going to take a very jarring jump from code samples in JavaScript to Rust. So here's an example of the infrastructure we built. A TurboTask function is a cached unit of work in our compiler. So we can, once you annotate a function like this, we can track it. We can construct a cache key out of its parameters. And that allows us to both cache it and re-execute it when we need to. These VC types here, you can think of like signals. This is a reactive value. VC stands for value cell, but signal might be a little bit of a better name. When you declare a parameter like this, you're saying, this might change. I want to re-execute when it changes. And so how do we know that? So we read these values via await. Once you await a reactive value like this, we automatically track the dependency. And then finally, of course, we do the actual computation we wanted to do, and we store it in a cell. So because we've automatically tracked dependencies, we know that this function depends on both the contents of the file and the value of the config. And every time we store a new result into the cell, we can compare it with the previous one. And then if it's changed, we can propagate notifications to everyone who's read that value. So this concept of changing is key to our approach to incrementality. And yeah, again, the simplest case is right here. If the file changes, TurboPack will observe that, invalidate this function execution, and re-execute it immediately. And then if we happen to produce the same AST, we'll just stop right there because we compute the same cell. Now, for parsing a file, there's hardly any edit you can make to it that doesn't actually change the AST. But we can leverage the fundamental composability of TurboPack functions to take this further. So here we see another TurboPack cached function extracting imports from a module. You can imagine this is like a very common task we have in the bundler. We need to extract imports just to actually find all the modules in your application. We leverage them to pick the best way to group modules together into chunks. And of course, the import graph is important to basic tasks like tree shaking. And so because there's so many different consumers of the imports data, a cache makes a lot of sense. So this implementation isn't really special. This is like what you would find in any kind of bundler. We walk the AST, collect imports into some special data structure that we like, and then we return them. But the key idea here is that we stored them into another cell. So if the module changes, we do need to rerun this function because we read it. But if you think about the kind of changes you make to modules, very few of them actually affect the imports. So you change the module, you update the function body, a string literal, any kind of implementation detail. It'll invalidate this function, and then we'll compute the same set of imports. And then we don't invalidate anything that has read this. So if you think about this in like an HMR session, this means that we do need to reparse your file, but we really don't need to think about how to do chunking decisions anymore. We don't need to think about any kind of tree shaking results because we know those didn't change. So we can immediately jump from parsing the file, doing this simple analysis, and then jumping right to producing outputs. And this is one of the ways we have really fast refresh times. So this is pretty imperative. Another way to think about this basic idea is as a graph of nodes. So here on the left, you might imagine a cold build. So initially, we actually do have to read every file, parse them all, analyze all imports. And as a side effect of that, we've collected all the dependency information from your application. And then when something changes, we can leverage that dependency graph we built up to propagate invalidations back up the stack and re-execute TurboPack functions. And so if they produce a new value, we stop there. Otherwise, we keep propagating the invalidation. So great. But this is actually kind of a massive oversimplification of what we're doing in practice, you might imagine. So in TurboPack today, there are around 2,500 different TurboTask functions. And in a typical build, we might have literally millions of different tasks. So it really looks maybe a little bit more like this. Now, I don't really expect you to be able to read this. Couldn't really fit it on the slide. So maybe we should zoom out. OK, so that is not obviously helpful. In reality, we do have better ways to kind of track and visualize what's happening inside of TurboPack. But fundamentally, those works by throwing out the vast majority of dependency information. And now I'm guessing that some of you maybe actually have experience working with signals, maybe bad experiences. I, for one, actually like stack traces and being able to step into and out of functions in a debugger. So maybe you're suspicious that this is a complete panacea. It obviously comes with trade-offs. And yeah, to that, I would, of course, say, well, what I'd actually say is all of software engineering is about managing trade-offs. We're not always solving problems exactly, but we're really picking new sets of trade-offs to deliver value. So to achieve our design goals around incremental builds in TurboPack, we put kind of all our chips on this incremental reactive programming model. And this, of course, had some very natural consequences. So maybe we actually really did solve the problem of hand-rolled caching systems and cumbersome invalidation logic. In exchange, we have to manage some complicated caching infrastructure. And of course, that sounds like a really good trade-off to me. I like complicated caching infrastructure. But we all have to live with the consequences. So the first, of course, is just the core overheads of this system. So if you think about it, in a given build or HMR session, you're not really changing very much. So we track all the dependency information between every import and every resolve result in your application, but you're only going to actually change a few of them. So for most of the dependency information we collect is never actually needed. So to manage this, we've had to focus a lot on improving the performance of this caching layer to drive the overheads down and let our system scale to larger and larger applications. And the next and most obvious is simply memory. Caches are always fundamentally a time versus memory trade-off, and ours doesn't really do anything different there. Our simple goal is that the cache size should scale linearly with the size of your application. But again, we have to be careful about overheads. This next one is a little subtle. So we have lots of algorithms in the bundler, as you might expect, and some of them kind of require understanding something global about your application. Well, that's a problem, because anytime you depend on global information, it means any change might invalidate that operation. So we have to be careful about how we design these algorithms, compose things carefully so that we can preserve incrementality. And finally, this one's maybe a bit of a personal gripe. Everything is async in TurboPack. And so this is great for horizontal scalability, but once again, it harms our fundamental debugging, performance profiling goals. I'm sure a lot of you have experience debugging async in the Chrome DevTools, and this is generally a pretty nice experience. Not always ideal, and I assure you, Rust with LLDB is like light years behind. So to manage that, we've had to invest in custom visualization, instrumentation, and tracing tools. And look at that, like another infrastructure project that isn't a bundler. OK, so let's take a look and see if we made the right bet. So at Vercel, we have a very large production application. We think it's maybe one of the largest in the world, but we don't really know. But it does have around 80,000 modules in it. So let's take a look at how TurboPack does on it. For fast refresh, we really do dominate what Webpack is able to deliver. But this is kind of old news. TurboPack for Dev has been out for a while, and I really hope everyone is at least using it in development. But the new thing here today, of course, is that builds are stable. So let's look at a build. And here you can see a substantial win over Webpack for this application. This particular build is actually running with our new experimental file system caching layer. So about 16 of those 94 seconds is just flushing the cache out at the end. And this is something we're going to be working on improving as file system caching becomes stable. But of course, the thing about cold builds is that they're cold. Nothing's incremental. So let's take a look at an actual warm build. So using the cache from the cold build, we can see this. So this is just a peek at where we are today. Because we have this fine-grained caching system, we can actually just write out the cache to disk, and then on the next build, read it back in, figure out what changed, and finish the build. OK, so this looks pretty good, but a lot of you are thinking, like, well, maybe I personally don't have the largest Next.js application in the world. So let's take a look at a smaller example. The React.dev website is quite a bit smaller. It's also kind of interesting because it's a React compiler. It's unsurprisingly an early adopter of the React compiler. And the React compiler is implemented in Babel. And this is kind of a problem for our approach, because it means for every file in the application, we need to ask Babel to process it. So, and fundamentally, I would say we, or me, I can't make the React compiler faster. It's not my job. My job is TurboPack. But we can figure out exactly when to call it. So looking at fast refresh times, I was actually a little disappointed with this result. And it turns out that about 130 of those 140 milliseconds is the React compiler. And both TurboPack and Webpack are doing that. But with TurboPack, we can, after the React compiler has processed this change, we can see, oh, imports didn't change. Chuck it into the output and keep going. Once again, on cold builds, we see this kind of consistent 3x win. And just to be clear, this is on my machine. But again, no incrementality in a cold build. And in a warm build, we see this much better time. So again, with the warm build, we already have the cache on disk. All we need to do is basically, once we start, figure out what files in the application change, re-execute those jobs, and then reuse everything else from the previous build. So the basic question is, are we turbo yet? Yes. So yeah, this was discussed in the keynote, of course. TurboPack is stable as of Next 16, and we're even the default bundler for Next. So mission accomplished. You're welcome. But And if you notice that revert thing in the keynote, that was me trying to make TurboPack the default. It only took 3 tries. But what I really want to leave you with, again, is this. Because we're not done. We still have a lot to do on performance and finishing the swing on the file system caching layer. I suggest you all try it out in dev. And that is it. Thank you so much. Please find me, ask me questions.
Please welcome to the stage Consent founder Christopher Burns.
Hey everyone, or I like to say y'all here, because obviously I'm from across the pond. It's my most favorite American saying. So I'm here today to talk about the one thing that everybody hates on the internet, and that is consent banners, cookie banners. So let's start with a common situation that most developers feel almost every single time we're putting a website into production. We tell the team, hey, the website is ready to go. We've ran the Lighthouse scores, and they are green, green, green. Success. And then the marketing team comes along and says, we just need to add a few scripts. And then the lawyers come around and say, you need to remember that you need to put the cookie policy and the privacy policy and the consent banners. So you do all of them things, and then the whole website's performance is broken. And this is something that is so common for all of us. And the marketing team will say, well, we need them to do our job. And the lawyers will say, we don't want to get sued. So why do we have to sacrifice compliance for performance? And I think that when we think about the European Union and around Europe, we've got this really big problem. So let's just get rid of that, just accept all, as we all do. And one of the biggest questions that always comes up, and back to the Lighthouse scores, is we see how it affects our numbers from greens to reds. And it's really hard to tell actually how much these things are impacting our websites, because things like our Lighthouse scores just don't say it. So what happens if we could actually benchmark these consent banners, the marketing scripts, to find out how much they're actually affecting our production websites? So I created a tool called Cookie Bench. Cookie banners, benchmark, bang it together, we get Cookie Bench. And it was made to showcase the performance of all the most popular consent management providers. So if you don't know, a CMP is what the category is around cookie banners. So you can find it on cookiebench.com. And here's actually some of the listings. So what we can see by this is we created a score. So we did all the best-in-class things that we'll speak about today, and we ranked all of these CMPs to work out things like network impact, time to first byte, but most importantly, the banner visibility. How long did it take for that cookie banner to show? If we're based in the European Union, every time you go on a new website, you look at your phone and you pause and wait, and then it pops up. Something that we've all felt. So some of the most important providers and some of the biggest providers that most enterprises are using, most of the biggest Next.js websites in the world are using, are slowing down the website. A 514 millisecond delay is terrible. So no matter how much we try and perfect the performance of using caches and all of this exciting Next.js React Server components, the marketing scripts will always ruin it, and the consent banners. So I started to notice patterns as I was benchmarking all of these tools between all the consent banners, is that They've got terrible dashboards that haven't even heard of things like Bootstrap, let alone ShadCN. All of them use script tags that sit on the header. Do I inline it? Do I critical it? Do I put critical flag on it? It's never clear, never implementing well with the modern tools that we use every day. But my favorite is no developer needed. All the big platforms are like, we do not need you to have the developer. You don't need to speak to the developer. We're marketers, we're lawyers. So I set out, when I created consent, to really redefine what I thought consent management was. And I was frustrated by all of the tooling out there never being quite good enough, never having React components or hooks or APIs. So I took all the best-in-class learnings from people like Vercel, Clerk, Resend, and I created C15T. What is C15T? Is that it's a brand new standard for the web, mobile apps, TVs, and even agentic flows that takes consent management, takes all the middle layers out, and creates C15T. Very much like we have I18N, A11Y, accessibility. So I really wanted to create this new open source standard that everybody could use to finally fix consent banners for everybody. So it's on GitHub, and we're currently at 1.3 thousand GitHub stars. I think it was this morning we hit there. So you can find it. Thank you so much. I really appreciate it. So let's actually explain what it is and why a developer will think, hey, I could vibe code this in 10 minutes. This isn't a hard thing to do. But actually, there's so many complications to it. So I thought about, how do I explain this to people? How do I explain that consent banners actually need two sides? First, the client, and the second being a server. So I created this Lego block system. So let's see how it works at explaining it to you all. So first, we're going to start with the consent banner, something that everybody knows. Here we go. And you may notice that it already looks slightly different to the consent banners that you're used to on the web. You're used to accept all being the main button. But the thing is, regulations are always changing. And as a developer, you don't have time to know which one you should use. So C15T has all of the best-in-class components to just do it right, as high-level abstraction as possible. This doesn't actually have any code in showing it, but this is like a simple JSX component. And what's really interesting about this is maybe you don't want to use our default blue, and you want to make it match your website. And this was also one of these core pillars when I was creating C15T that I felt like every solution sucked on. I wanted them to handle the logic, but I wanted to make it feel like my brand. So I wanted to, in this use case, remove the rounding on the corners, make it yellow, add my own font face. But what happens if you wanted to completely customize it and go further? So instead of using our best-in-class components, you can opt for a headless mode and even bring your own components or use something like ShadCN. And this is another example. So that's consent banners, styling, and then one of the next fundamental pillars is I18N. So when we think about consent banners, we think about the English web. But in the EU alone, there's 24 native languages, 24 languages that you need to support to handle things like GDPR. So things like internationalization is built in. For example, in the UK, you will see English. In places like Italy, you'll see Italian, and even French. So that is styling, the consent banner, I18N, and you think, that's it done, right? But something that a lot of developers also forget about is that you need to also build in a consent manager to allow your users to change the consent on a fine-grained permission. So for example, when you click customize, you'll see the consent manager. and it will show all the categories that are currently active on the website and allow the user to, sure, accept all, but in most cases, less. So this is taking all of these best-in-class components, and these two are the main and critical ones that most people will know and need. But the other things that are important is things like frames. So this is a new component that we added just 2-3 weeks ago. And this is to also wrap all of the things like your iframes. So if you're a CMS or an e-commerce website, you need to put them YouTube videos in frames. So that cookies, that third-party data cannot leak until consent is given. And what we have to remember here as well is that everybody, depending on their region, will get different results. So in places like the US, you won't see the frame, but in places like the European Union, you will. And obviously, when we click that, we get a little video. So one of the really big final things is that it's great to provide components, and we've already spoken about the headless mode, and I really set out to make C15T as customizable as possible, no matter if it was server-side rendering, client-side rendering. But one of the most important things was the hook system. And one of my favorite hooks that, if I had to pick one to display, is the has capability. So during things like our dashboards or our marketing websites, we need to conditionally render scripts or maybe components, depending on if marketing has been given consent or analytics. You may even want to go more spicy and go marketing and analytics, or a really complicated statement. And what's really interesting about things like this API is right now, we're just using things like GDPR categories. But C15T is built to be an agnostic consent engine. So you could quite easily be saying has cloud access or has bank account access. We're just currently using it for the GDPR categories, and we'll be expanding out soon around this area. So that's a quick overview of why just building a client-side consent banner is more complicated than you think. But obviously, we had the other side, that's the server. And now this one was really hard to visualize when I had to make this block system. So let's give it a go. So one of the most important things for a consent banner is geolocation. And this affects not only Europe, but also Americas. And why? Because in places like Germany, you should see a cookie banner. In places like the UK, you should see a cookie banner. But then the US, no. C15T is intelligent to only show the cookie banners and consent banners where they are needed. And that has a two-tone effect, as in, one, people in places like California, where we are now, cannot sue you for having a cookie banner, and that has came across our desk already. But secondly, even though the consent banner is not being shown, C15T is still running in the background intelligently, activating all the things to handle them consents. So again, in the US, if the website uses C15T, you should never see another consent banner. Even places like Australia and the Netherlands, you will. So what is next is I18N. And we've already spoken about I18N on the client side. But again, one of the biggest things about C15T is really pushing the edge on performance. If this is something we all have to do, why can't it be a Ferrari? Why can't it be as best as possible? So if you think back to what I said earlier, there's 24 native languages inside the EU. So that would mean bundling 24 languages. So part of C15T is server-side rendering them. But it comes at a catch. And a lot of other CMPs get this wrong. So let's explain why. So if the device is in Germany and the language is also German, then you should see a German cookie banner. But if the device is in Germany, but say the language or the website is in English, then you should see an English cookie banner. And a lot of the current solutions get that wrong. So that's IoT-NN and server-side languages. But what else is really important? So why even have a server? Is because to do things like GDPR correctly, or even other regulations, you need to store the consent in a database. So when we was building C15T, we said, hey, why don't we support Postgres? But also, why not MySQL? And then SQLite, and then Mongo, and CockroachDB, and hey, why not stick Microsoft SQL in there as well? And the other thing is, we're supporting all these databases, so how are you actually going to get access to that consent data, no matter if it's GDPR or for agentic flows, like accessing consent? Is using things like an ORM. So in terms of ORMs, we support Drizzle, also Prisma, TypeORM, and also Keithly, the whole package. So that was really impressive to build out and get working. But the really big thing as well is maybe you don't have access to the database. You don't have access to the ORM. So we still wanted to think about every layer so important, and think about the composability. What about if you can't use our best-in-class JavaScript components? What happens if it's a PHP website or a Ruby website? So we support things like OpenAPI, so you can easily access every API functionality. But the biggest thing that we're also building out is things like Node SDKs and other frameworks as well. And this is really important for things like then agentic flows. So not only can you save the consent to the database to say, hey, in this example, we're using consent banners, but it could be something like agentic flows, it could be bank accounts, so much more. You can also retrieve it through a type-safe SDK. So that is a really quick tour of the client side and the server side, and why it's so much more complicated than a 5-minute vibe coding job, and why you should use something like C15T that we have built to be an open web standard. So how do we build it to be an open web standard is that you can self-host C15T, the front end and the back end. And one of the most powerful reasons to self-host C15T's back end is for data residency. So people like banks or specific European countries where they're very restrictive of where their data is actually saved can actually host it themselves. And to be a web standard, it should all be open source. So that's self-hosting, but I'm here to also, as the founder of Consent. So what actually is Consent is that it is a hosting platform for C15T. So we really think about this in a way of, if it's something purely for a developer, then it goes into C15T. But if it's something for your legal departments or your marketing departments, that's where you really need a full observability in a dashboard where you can spin it up, where you can say, here, I've implemented it from the developer side, now you can hand it off. So that is where we set up Consent. So that's really cool, and I always want to do one of these things like one more thing that I wanted to cover. And this is a brand new component inside the Next.js package, and it's client-side for a reason. And we always thought back to the start sides of, we've handled the consent management, we've handled things like showing the consent banners, but also what about the marketing scripts? So we built a type-safe system for marketing scripts. Things like your Google Tag Manager, as we can see. It should be simple, easy, and type-safe. So we call this C15T scripts, and C15T is built to be very composable, as small a bundle size as possible. So what kind of integrations have we already built? Things like PostHog, Metapixel, Google Tag Manager, Analytics, Xpixel, LinkedIn, and even things like TikTok and Microsoft UET. This is a really important step for Consent and C15T because we're trying to say, hey, let's normalize all of these different marketing scripts into a new type-safe system that a developer can simply implement once. The consent and the categories are automatically defined to really stop that performance lags that we see. So when we talk about them performance lags, Guillermo asked me many times, how fast is C15T? So back to our benchmark. And C15T is incredibly fast with an 89 millisecond banner visibility. And when we set out our scoring system that has all the best-in-class accessibility, also best practices like we spoke about with geolocation, I18N, we also crush it on the scores. So what does that actually mean? Thank you. So what does that actually mean to the industry leader? Is quite a lot, as you can see. And to really say again, 89 milliseconds, that is at the price of being dynamic. So 89 milliseconds for showing a cookie banner in the EU or the US, you won't even see one. Incredibly fast. And that's 7.9 times faster than the slowest consent banner that we benchmark. And 1.9 times faster than any other benchmark banner that we put on there. So C15T is bundled by default. And one of the big reasons it can be so fast is also that it's got 0 third-party requests. When it's loading onto your client, it is bundled versus all of these other CMPs that will start a waterfall effect. So if you're on a slow connection, expect them load times to be even slower. The average is 5.6 out of all the ones that we have benchmarked. So, that's C15T, and yeah, we're growing really, really fast. And you can find C15T at c15t.com. But one of the also really exciting things is if you've got a Next.js project, a React project, you can put into your terminal npx at C15T CLI, and within 5 minutes, all of them cookie banners, GDPR things will automatically be set up in your Next.js application. So there's a last few things I want to cover just to wrap it all up. So we've talked about the technology, but some of the most important things here, and the reason we create C15T, is we don't teach the regulations. We teach the abstractions. As a developer, you shouldn't need to know the difference between GDPR, CCPA. You should only need to know the abstraction, things like the consent banner. And why is that? It's because regulations are always changing globally. And how are you meant to keep up to date with that? You're just a developer. You have so many more things to do with your time. And that's why we shouldn't let regulation slow down our innovation. We should use these tools to help increase that. So the hosting platform of C15T Consent is growing really, really fast. And week on week, we've had some amazing companies joining us. And we really can't wait to keep on growing. Excited to have everyone and really show off how good this can be. So my real final slide is i5 for the users. And this is something that the whole presentation is not speaking about. It's not speaking about the developer. Well, the presentation is speaking about the developer or the marketing or the legal. But the most critical thing is the users, is all of us who have to use the web every single day, or when we think about future agentic flows and how consent is given, it is really important that we actually think about how these tools we're using affects the users. And that is why I set it as my goal with C15T to create a new standard. And obviously, that's from Tron, if you didn't know. So just a quick roundup of links. So you can find C15T at c15t.com. All of the benchmarks, and there's so much more that we could have spoke about around the benchmarks, from waterfalls to the tests that we run at cookiebench.com. And to get started really fast with C15T is consent.io. Thank you so much for your time today. And we just really want to make the web better for everybody. And you can find me on places like Twitter, LinkedIn, but most important, starring us on GitHub is one of the most incredible things to really show people why this is important. Thank you so much for your time.
please welcome to the stage Bun Staff Developer Relations Engineer, Lydia Halley.
Hi, everyone. I'm Lydia. My title is actually Head of Propaganda at Bun. And if you know a little bit about me, you know that I love talking about JavaScript runtimes and performance. Actually, before I joined Bun, I was at Vercel for a couple of years to teach Next developers how to build apps faster. So I'm very excited to be here today and show you how much better it can get when we combine Next framework performance with Bun's runtime performance. But before I talk about Bun itself, I want to take a small step back and show you what makes frameworks like Next.js so special in the first place, because they truly redefined how we see performance on the web. It didn't just make websites faster, it streamlined every part of the process. We got smarter bundling with Webpack and now with TurboPack. We got a built-in image and font optimization. We got efficient server-side rendering, static site rendering, and now we got ISR, and now I guess RSC to bring data fetching into the component itself. And all of these improvements kind of pushed what the framework can optimize, but really only up to a certain point. There's always been this one fundamental layer that Next.js hasn't been able to optimize yet. And this is not because of lack of engineering effort or capability, but it's just outside of Next's scope. And that is the runtime itself. Normally, when you run Next.dev or you deploy to Vercel, your Next app runs on Node. So this means that Node's runtime executes your JavaScript, it manages the event loop, file I/O, everything, and it bridges your JavaScript code to the operating system. And this makes sense because Node has been, the default runtime for the past 15 years or so. It's battle tested, it's reliable, but in 2025, it's also become a bit of a bottleneck. Don't get me wrong, Node is fantastic. It, made it possible to run JavaScript on the server. Before that, before Node was introduced in 2009, JavaScript was really just for the browser. Node changed that by giving us a runtime with a JavaScript engine, an event loop, async I/O, and APIs to do all the things that browsers cannot do. So reading files from disk, memory, all that stuff. Now, under the hood, Node uses the V8 JavaScript engine. This is Google's fast Chrome engine, which is great for long-running tasks, like a tab in your Chrome browser. But of course, V8 is just an engine. It only knows how to execute JavaScript. It cannot open files, make TCP connections, and all that kind of stuff. So that's where Node's built-in APIs come in. So FS, HTTP, NET, and so on. So these APIs are kind of the bridge between our JavaScript code and the operating system. And these APIs itself rely on a C library called libuv. This isn't built for JavaScript itself. It's more of a generic abstraction that Node uses to be able to do stuff like file I/O, networking, and stuff across all these different operating systems. So, when we call something like fs.readFile in our JavaScript code, we're really just asking the computer, I want to read this file from disk. But before we can get there, it first has to go through V8, then, or from a JavaScript code to V8, then it passes it to the Node C++ binding. This then calls libuv, and this is not even mentioning the thread work and all that kind of overhead. And only then libuv actually makes the system call to our kernel to actually get this file from disk. And while that's all happening, we have the event loop that libuv uses so the rest of our JavaScript code can still execute and so on. And this model works fine. We're still using Node, but it's not optimal. So back in 2009, so again when Node was introduced, our hardware looked very different. Servers maybe had 4 cores, limited memory, and storage was pretty slow. Threads were also expensive, so creating a new thread for every connection just didn't really scale well. So Node's model was great for that era because we could use one thread to handle thousands of connections really efficiently. But fast forward to 2025, our hardware looks very different. We now have hundreds of CPU cores, terabytes of memory, and storage is like 50 times faster. But we're still using like Node's model based on 2009. It's still pushing everything through that same event loop. And again, this is fine, like Node's architecture is fine when servers ran for days, but in modern times, we often have like serverless functions, or we have dev servers, all these more like short burst scripts that need to start up fast and run for a much shorter amount of time. So in these environments, every millisecond of startup and every like data layer matters here, because they all add to latency. Now again, when you run your Next app, you are running it on Node. So this means that everything that your app does, so like rendering pages, serving assets, streaming responses, they all go through all these layers that we just saw. So from JavaScript to V8 to Node, all that kind of stuff. And Next has done an incredible job at squeezing every bit of performance, kind of despite having the Node runtime still blocking certain things. Because at the end of the day, all these improvements still run on top of Node. So when you spin up like a dev server or rebuild files, hot reloading, you're still hitting those runtime limits. So if we really want to go faster, we have to look beyond the framework. We have to go a level deeper. We have to rethink the runtime itself. So that is where Bun comes in. Bun is not just like another layer built on top of Node. It is a brand new runtime built from scratch for the hardware that we actually have in 2025. So instead of being written in C++ on top of libuv like you saw with Node, Bun is built in Zig. And this is a modern systems language that runs much closer to the metal. So for the JavaScript engine, Bun uses Apple's really fast JavaScript core engine. And this spins up really fast, mainly because it can like defer some of the initialization optimizations that engines like V8 make. And it also just runs really quickly, which again is perfect for kind of the modern tasks that we use nowadays with dev servers, serverless environments, and these shorter build scripts. The core runtime itself is written in Zig, so the Bun APIs and all the parts that handle async I/O. So where Node uses libuv for all of these async operations, so like file or like reading files, network requests, and so on, Bun can implement these as direct system calls to the operating system because it's written in Zig. Now, for network requests, we use usockets, so it's a bit different, but we're removing so many layers of abstraction by using Zig instead of libuv. So now if you want to read a file with the Bun runtime, it still goes, of course, from your JavaScript code. It now goes to the JSC engine, to Zig, which can then make that direct system call. So again, fewer layers between our JavaScript code and the actual operating system. And the result here is that everything feels so much faster, from startup to file access, HTTP servers, and so on. But Bun is not just about performance. We also aim to be 100% Node compatible. So we want to make sure that all of Node's own APIs work, but then it also ships with tons of additional built-in APIs like S3, SQL, or Squeal, whatever you want to say, Redis, hashing, a shell, so many things. And if you've ever used other programming languages like Go or Python, this kind of like batteries included approach is very familiar to you. But as JavaScript developers, we've just gotten so used to installing dependencies for pretty much everything. Like, I use like password hashing in almost all my apps, but I still have to install a dependency every time I'm using it. So Bun changes that. The stuff that you use pretty much all the time is just built right into the runtime itself. It's just built on the global. And again, these are not just like surface level wrappers on top of an NPM dependency. They're truly built in Zig. So they're optimized for performance for the modern hardware. So for example, Bun has a built-in SQL client. So you can connect directly to Postgres, MySQL, and SQLite using a single API. You don't have to install any additional dependencies. And again, this is not just calling some NPM package. It is truly all Bun just talking directly to the system. And it's not just convenient that we have these built in. Bun's options are usually also a lot faster than the Node and NPM alternative. So for example here, bun.sql is up to 11 times faster than MySQL 2 on Node, which is really good. Or you can use like Bun's S3 client, and this works out of the box with any S3 compatible storage. So Amazon S3, Supabase storage, Cloudflare R2, you name it. And again, also this API is incredibly fast. So here we can see that it's up to like 6 times faster than AWS S3 SDK on Node. Now, of course, you can still use your normal dependencies with the Bun runtime as well. You don't have to use these built-in APIs. But they do reduce your bundle size a lot because we're no longer adding these dependencies. And it helps with NPM vulnerabilities that we saw like last month because you don't have to install them. There's tons more APIs. I highly recommend that you check out the docs as well. But Bun comes with way more than just a runtime. It also ships with a really fast package manager that's up to 17 times faster than Yarn, 7 times faster than NPM, and 4 times faster than PNPM. And the good thing, you do not have to use the Bun runtime to use Bun install. And this is just, you can use Bun install with Node. It will just work. So you don't have to change anything about your project. It also has a really fast built-in bundler and transpiler, so you can serve and build your files instantly. So you don't need Webpack, ESBuild, no extra setup. And the nice thing is also supports TypeScript and JSX right out of the box. It also has a really fast test runner that's up to 14 times faster than vtest and 23 times faster than Jest when we SSR'd like 1,000 React tests. So again, you get really fast tests. You don't have to install anything. So this all sounds great, but how can we use the Bun runtime in Next? Honestly, it's really simple. After installing Bun, you just have to update your start command or your dev command and add bun run -- bun. That's it. You're now running the Bun runtime. Now, you might be wondering, why do I need that -- bun? Like, I'm already saying bun run. That's, again, because Bun really cares about Node compatibility. So normally, like if we just use like bun run next dev, Bun will detect that next CLI uses that Node shebang. And in that case, Bun will be like, OK, I understand that I have to use Node, so then it will just default back to Node, even though we said bun run. But with the -- bun flag, we're kind of forcing that to skip the shebang and say, OK, we're just using the Bun runtime. So just as kind of an extra explanation. So now with this command, Bun starts your Next dev server. The bundler itself is still Next, so that's still TurboPack, I guess Webpack, TurboPack, now it's the default. But now the runtime underneath all of that, so the thing that's executing your JavaScript, reading files, serving responses, and so on, that's all Bun. And because Bun is designed to be Node compatible, you shouldn't have to change anything about your code. All your packages, all your middleware, everything should still be working. If it doesn't, that's also considered a bug in Bun. It should be 100% Node compatible. So if you're trying this, you run into issues, let us know. But you shouldn't have to rewrite anything. And now that your app runs on top of Bun, you get access to all of Bun's built-in APIs. So for example, we can just use the S3 client right in like a server function, and React Server component, and so on. So we don't have to install any dependencies. So just to compare what it normally would have looked like with Node, you can see that with Bun, we have a lot less code, we have fewer dependencies, and it's instantly compatible with all the other S3 providers as well. So if you want to change from Amazon S3 to like Cloudflare R2, Supabase storage, all these other providers, that's super simple. Or a more like complete one, we can use S3, the Bun shell, and SQL directly in a React Server component. So first, we query the database with SQL to fetch a blog post, generate a pre-signed S3 URL for the image, use the Bun shell to count the words. Again, there's no extra API layer or third-party tools that Bun is calling. Bun handles the runtime, the database connections, and the shell all natively in Zig, so close to the metal. And again, of course, it's not just S3 SQL. We get access to all of Bun's APIs by just adding bun run -- bun in front of next dev. But of course, now you might be thinking, OK, I'm not using Postgres. I'm not using S3. I'm not using any crazy dependencies, so why should I care? The thing that got me into Bun before I joined was honestly just the incredible DX. You can just run any JS TS, TSX, JSX, doesn't matter file without any configuration. It just works. You don't have to think about TS Node, Babel, SWC, and so on. So even if you aren't using Next, even if you're just developing, you want a quick build script, just using bun run, just try it. It makes your life so much better because you don't need any configuration. Bun also comes with bun X, and this is bun's kind of equivalent to npx. Again, you don't have to change anything. You don't have to use the bun runtime for this. You can just change npx with bun X, and you see instant startup improvements. So for example, using bun X create next step is 5 times faster than npx create next step. And you don't have to use the bun runtime for this. It's just a lot faster. Then of course there's also bun install, which again does not require you to change the runtime. It just makes your installs so much faster, also on basic Next projects. Now, obviously, running bun locally is one thing, but how do we deploy apps that run on bun? Because this is, of course, a whole new runtime. Now, you can already use Next.js on bun on several platforms like Render, Railway, or containerize your app with Docker. But we're all Next.js developers. Ideally, we also want to be able to deploy to Vercel. So naturally, we tweeted at Guillermo, kindly asking him for native bun support on Vercel. And we quickly got a pretty promising response. And then a couple weeks later, bun support has been achieved, at least internally. So I'm very excited that native bun support will come to Vercel very, very soon. And this means that you'll be able, yes. Applause goes to the great engineers at Vercel that made this possible. But this is very exciting because this means that we can now run bun apps just as easy as any other Next project on Vercel. So also just a real-world example. I'm not sure if you can see it on the screen, but running a Hono API with bun already saw a 30% drop or CPU drop by just running bun on Vercel. This is, of course, a different framework. This is Hono API, but it's the same runtime benefits that you will get if this was a server function, RC, and so on, because bun saves a lot in CPU and memory usage. Now, we, of course, don't have to wait for native bun support to start using it in our apps. The simplest way is kind of to start using it or to adopt it incrementally. So first, I recommend just switch to bun install. Changes nothing in your code base. This just uses bun's really fast package manager. Also, if you're interested in knowing why bun install is so much faster, I wrote an article on this not too long ago. I highly recommend you check it out. It just explains, we're not just skipping steps or doing whatever. It kind of explains the systems engineering behind it that makes it so much faster. Now, after using bun install, then try to use the bun runtime. You can just use it locally with bun run -- bun. Test your app, see if everything works. It should. If it doesn't, let us know. And then lastly, you can kind of incrementally move to bun's native APIs where it makes sense. You can, of course, still mix and match these NPM dependencies. But the best part is also that each step here is reversible. So if you did use one of bun's native APIs and it didn't work, you can always just switch back to Node. But it's definitely worth checking out. Now, before I end this talk, I just want to say a really big thank you to the amazing team of engineers at Bun. Most people might know Jared, but there's an entire team behind Bun that works so hard every day to make Bun even faster, more stable, and so much more fun to use. They're truly pushing the limits of what's possible with JavaScript. So next, reimagined how we build for the web, but Bun reimagines what powers it. Thank you so much for coming to my talk, and I'm so excited to see what you'll be building with Bun and Next.
And now, please welcome to the stage Vercel Head of Developer Community. They call her Cap Sev.
Aloha, everyone. Aloha, friends. My name is Cap. I am the Head of Developer Community here at Vercel. I see a lot of my friends in the crowd. Hi, everyone. So we run the open source program at Vercel, and I know that the open source community is a very important subject to many of you here today. So bringing the creators and or builders of Next.js, Svelte, and Next on stage was something that really mattered to me because I know it matters to you. And in all honesty, when Svelte and Next Labs joined Vercel, I know it sparked both excitement and curiosity. People started asking, what does this mean for the future of my favorite framework? So I wanted to create space during this conference to hear directly from the folks behind these tools, to ask them about the future, about open source at Vercel, and the web in general, and maybe we'll find out some fun facts about these builders. So this panel is about transparency, curiosity, and celebrating open source. I always say it, but the world runs on open source, so let's chat with some of the builders in this community. So let's bring to stage Tim Newtons from Next.js, Rich Harris from Svelte, and Sebastian Chopin from Next to the stage. All right, so we have Tim, Rich, and Sebastian, all builders of frameworks we use and love. Who's using one of these frameworks? Next, Svelte, Next? Nice. So let's start with intros. Could each of you introduce yourself, what your role is in the particular framework, and give us a sentence that captures your framework for someone that's new to it?
That's good. Hey, I'm Tim. I work on Next.js mostly. Nowadays tech lead, but yeah, started Next.js together with Guillermo.
Nice.
Rich?
Yeah, I'm Rich. I've been working on Svelte for the last 9 years, working at Vercel for the last 4 of those years. There's a team of 3 of us who work full-time on the framework within Vercel. I manage that team. The pitch, I mean, if I was being cheeky, I would say React without the BS, but this is Next.conf, so I have to watch my words. It's a way of building resilient and accessible web apps more easily than with alternative tools. It's a framework, but it's also a compiler and a language. You should check it out.
And I'm Sebastian Chopin, the author of Next. I joined Vercel with Next Labs acquisition 3 months ago. If I have to compare, if you use Next.js, I guess you are here. Next.js is the Vue alternative, and we have maybe more feature, less feature. This is a matter of taste. I highly recommend you to check it out. With my team, we're also working on Nitro, which is the server part we extracted 2 years ago with Next 3 that is now compatible, that you can use as a backend framework, but also use it as a Vite plugin if some of you are using Vite.
So you said 9 years. Next is also at 9 years. And what's Next at?
9 years as well. It
Oh,
was
really?
The 26th of October, 2016.
Awesome. So why did you build it? Why did you build Next?
Yeah, I was making an e-commerce website with Vue.js and server-side rendering. Back then, Vue 2 was not there. It was in 2015, so I was using pre-rendering with a headless browser. And then I was following Guillermo, and I saw the announcement of Next.js. And I gave myself the challenge to do the same for Vue. And a week later, I had the first prototype working.
Oh, that's cool. What about you, Rich? Why'd you start Svelte?
It was guilt, partly.
Okay.
It's actually my second front-end framework. I'm a serial offender. And the first one was just like kind of bulky and a little bit slow, and I just wanted a do-over. And having spent time working in the compiler space, I created a module bundler called Rollup. And so I was learning what you could do with abstract syntax trees and all of that. And I thought, what if we can apply these ideas to frameworks and do the work instead of doing it in the browser? Like, you do a lot of the work as part of your build step and make everything faster and more compact. And so it kind of started out as, you know, atonement for my sins in the earlier project, but also as an experiment to see how far you could push that idea of doing ahead of time work. And the reason that I was motivated to do this was because my background is actually in journalism. I was working in newsrooms, building interactive visualizations, which tend to be very heavily interactive. You're dealing with large amounts of data, motion, things like that, and you need something that is capable of moving a lot of pixels at 60 frames per second, even on mobile devices. And the tools that were around at the time weren't really up to it. So that's where it came from.
Nice. Tim?
Well, if you're here, you might already know the story, but we basically started by, so this is before I started contributing to Next.js, but we started building this, like the dashboard for Vercel, actually, like what turned into the dashboard that you use maybe every day if you're a Vercel customer. We basically didn't have, like Guillermo had a very like clear vision of like what he wanted this kind of thing to look like, and also like how the actual like development on it should work. And he wrote this blog post. Forgot the name of it, but you can still find this on his blog, and it was basically like what should a framework look like in 2016 before we had all these different paradigms. One of the big things was like server-side rendering. You think like we immediately chose React, but actually we didn't. We chose to build our own like React-like thing that was like a templating language. It's called N4, and eventually like they decided to pivot that to a like React-based framework, which was React wasn't as popular at the time per se, and we basically started like building with like server-side rendering and doing all of that. And then like over time it evolved into doing like more static generation, other things as well.
Cool. It's fun because like these are frameworks that are all like being used by so many of us, but there's just like this unique story that made them start. So it's like really cool to hear that. So I engage with a lot of the open source community, and people have a lot of mixed feelings about open source projects. Like code exposure, I think, is the biggest one. Like, oh, I got to keep my code safe. I don't want to open source it. But then others think it's super important to be a part of the open source community and have the contributions. So why open source? Why is open source so important to you?
Honestly, it never even occurred to me to not do things as open source. It's just kind of how software is written, particularly if you want to get users.
Yeah.
Which, I mean, I don't know, it's like having users is a blessing and a curse. But if you want any kind of adoption, then you've got to be open source, because otherwise someone else is going to do an open source version and that is going to be more popular. But there are also like very tangible, concrete reasons why it's beneficial to the software itself for the source to be open. And I'm sure like you've had similar experiences of, you know, you throw something over the wall and then someone comes up and says, oh, hey, there's a security vulnerability that you might not be aware of. And if the source wasn't available to them, then you'd just be sharing that vulnerability with your users. So yeah, it just never occurred to me to
I think for you, it's also what I found really interesting for your case is like you said, you're a serial open sourcer, and you created many projects. But actually, many of these projects that you are talking about, they still exist today, right? So you're obviously working on Svelte, but then you created Rollup. But actually, you're not working on Rollup day to day. At least I think so. But there's like someone else that came in that is now working on it, I think like even full time or something like that.
Right. The longevity is. Like,
yeah, so it's like even like there's this thing with like if you don't open source your software and you lose interest, or like I'm not saying you lost interest, but it's more like you live and you learn new things and you start building even more software and maybe something like that. And what I also found really interesting for the projects that you build is that they end up like going over this lifespan of just like you being the maintainer and creating it, to then also getting more users, but also the users starting to contribute back to it, and then also like outliving you as the like rollup guy basically, or
yeah,
like that.
Yeah. I mean that's absolutely essential, and like I think we probably all would say that we learned how to be developers by reading other people's source code.
Yeah.
And like it sounds a bit like kumbaya to be like giving back to the community and everything, but actually that is how we create the next generation developers, is by giving people the ability to learn the same way that we did. And so I think it's just essential that we continue to prioritize open source over the alternatives.
And I do think that if you want to create a community, it has to be open source. So I think it might be very hard. And if you want to get some help, it's also easier if it's open source. It might be frightening to push your code as open source, but you may be surprised that not everyone look at your source code. Potentially they look at some files, or it's the same thing as you have this feeling that everyone is watching you if you are on stage, but probably not. Maybe everyone is watching
Yeah,
Twitch
they're
right
all
now.
on their phones.
Yeah.
They're all on their phone, actually. And it's quite similar on the open source. Like, most people won't read your source code. They will probably read the documentation, but they will have trust by knowing they can look at the source code at one point and be able to contribute. So I saw only benefits of open sourcing it. And at one point, if it becomes popular, the maintenance might become a burden, but the beauty of open source is you can find help quite easily. So this is something that I highly recommend for you to try.
Speaking of the community, what has been the weirdest, quirkiest contribution you have seen, and did you accept it? Quirky.
It almost sounds like like you're looking for the Guy Fieri in Babel thing. So at least someone in the audience knows what I'm talking about. No.
Yeah, the Babel thing. There is one thing that springs to mind. So the project I mentioned that was Spelt's predecessor, it was, you know, you would have a JavaScript file and you would instantiate a component inside it and you would pass it a template, which is like this HTML-ish thing, and it would just be in a giant string that you pass to the constructor. And one day this guy comes along and says, I want to have my JavaScript and my HTML like in the same place. And I was like, what do you mean? They are in the same place. It's like, no, I don't want to put my HTML in my JavaScript. I want to put my JavaScript in my HTML. I was like, what the hell does this guy mean? And after a bit of a back and forth, he was like, no, if you have your component in an HTML file, and then you have a way to import that, and it becomes a JavaScript component, then everything is just kind of much more neatly organized. And you can put your JavaScript inside a script tag because HTML can contain everything else. I'm like, while we're at it, why don't we put our styles inside a style tag? And it was, I didn't see it at all at first, but he convinced me, and that is how single file components were born.
Wow.
So this, I remember, like, this is like 11 years ago, the guy's name, Dave Marshall, very influential figure in front-end development because we did that, and then Vue adopted it too, and now it's just how some frameworks work. And it was just because some guy had an idea and thought, I'm going to raise an issue.
Yeah.
Power of open source.
That's cool.
So someone had, you're saying someone had strong feelings, and that affected like millions of developers, basically.
Open source.
You won.
Nice.
Yeah.
Good on you, Dave.
Mm-hmm.
Well, I think recently we had an issue on Next.js. Someone saying that, can you please rename this prop because the LLM doesn't assume that it should be the right prop. Like it was a U table. I think we're using 10-stack table under the hood. So obviously we give this data attribute to give the whole array to generate the table. But because the LLM was expecting to use rows, we should rename directly the attribute. So at least it gives thinking that potentially with the rise of LLM, shall we also try to either educate the LLM of this new prop or just go ahead and trust what the LLM is expecting for us to. So maybe the LLM will be the one making the craziest ideas for frameworks. But yeah.
That's a good point. Have you had to change much with the framework with AI? Like, is there a lot of issues that are coming up that you're like, oh, I would have never thought of that, but this LLM issue is showing itself?
There are some things that I think, like, at least I as a programmer never did. It's like running the Nexus dev server and then also running Next build.
Mm-hmm.
Because like every change I make, I'm like running Next build to verify if my thing is correct. Like I never did that myself. And then when you start getting like agents that are like automatically like verifying their own work, like you get people to do Next build. But we never thought about it in that way like at all. So there wasn't even like a good error message for that. Like if you do that, so what happens is like you run Next build, it breaks the entire app. Like your development server is broken, you have to reboot, start over. But now with the instead of like agents or like AI writing code and verifying itself, you basically end up having to take all these like new DX features into account that are like sort of like geared towards like AI more. And there was like one example, like it was for us, it was like a one-line change to the config by creating like a new dist directory for build or for development, and then like for build it uses the same thing. It doesn't break, but that like one-line change was received so well because like everyone's running into day-to-day at this point if they're using AI. Yeah, that was like one that immediately comes to mind for me.
Yeah.
What about you, Rich?
We haven't changed anything in the design of the framework itself for the benefit of LLMs, but people do run into the reality that if you're using Claude Code to build your Svelte app, it's probably going to have more Svelte 4 in its training data than Svelte 5, and we changed a few things. And like you just can't get the LLM to generate modern idiomatic codes. So we have released an MCP server that really helps with that. Shout out to Paolo and Stanislav on the team who put that together. But most of the conversations that we have about if there is something that we need to do differently for LLMs, it's about making the documentation more digestible. And we are loath to do something purely for the sake of LLMs, partly because we think of ourselves as engaged in a very human-first project.
Yeah.
But partly because it's such a moving target. Like the things that are beneficial for LLMs today are not the same things that were beneficial 6 months ago and are almost certainly not going to be beneficial 6 months from now. So we always think, okay, is this change, like making more digestible documentation, something that is also going to be beneficial to humans? If so, yay, let's do that. If not, let's just hold our fire for the minute and see how things shake out.
Because Svelte 5 is new this year.
It was released last October.
Okay.
Yeah, but
And it's still not on 5?
It's version 5, yeah. And so the newer models, their cutoffs are after that date, but I think there's still more of the old stuff in the training data for most of these models than there is the new stuff. And this is not a problem that's unique to us by any stretch. I mean, I'm sure that it's going to take a while for new React patterns to get adopted. And
this is like part of why we're also introducing the Next.js evals so that like AI labs can use that.
Mention it as well. Yeah. Well, at first, when I saw that the LLM was trying to put React code in my Vue app, I was considering to support React, but then I was like, okay, let's see how we can help the LLM to read the Nux docs. So we started with this /LLMs.txt, being able, based on the adding this .md suffix to other pages to serve the markdown, so it's easier for the LLM to crawl our documentation. We recently released this Nux.UI MCP server. The Nux MCP server is coming end of this week. And we noticed a better code output from the LLMs. And lastly, we've been also teaming up with the Vercel and Next team to build these evals to compare the different AI models about producing proper code. So we had some tests. We make sure we give a prompt and we compare the output. And it helps us to see if the MCP is doing a good job or not. Maybe it can be part of the prompting. So if we notice that always pasting these sentences in the prompt always give us a good result, we will try to advocate having these agents.md. But we go step by step, like Richard said, it moves very fast. So we also need to focus on the human. So trying to juggle between the two and listen to the community. Yeah, that's how we do it.
So I always think of open source as that like building block thing, and then you have like the one tiny one that if it goes away, everything crumbles. That's like open source. That's like the one open source package
the
for all.
random guy in Nebraska.
Yeah. So it's the foundation of a lot of projects. And it can also be a lot handling like issues and then keeping the community energy up. So how do you keep the momentum going in your community for Next, for Nux, for Svelte? How are you handling those issues, making sure your community's happy and staying true to open source?
I mean, anytime you start an open source project, you have to wear all of the hats. Like you're pushing all of the code, you're writing all of the docs, you're doing the logo design, and you're building the website. If there's tooling involved, like ESLint plugins and stuff, you've got to do all of that yourself, and that quickly becomes a lot. So the one thing that I'm glad I learned quite early on is if anyone shows any inclination to help whatsoever, you bear hug them and you put them to work. And the thing that I think is really crucial with that is if you find people who are community minded, who are good at helping other people who are like less far along their learning journey, and can help answer their questions, help respond in GitHub issues or in Discord threads, those people are absolutely worth their weight in gold. Because if you're working full time on the code and the design of the framework, like you really don't have the bandwidth to be also like customer support. And so if you can divide that labor, it will save you a lot of trouble. I imagine we've all found that.
I think you cannot do it by yourself. At one point, you need help, and embracing people helping you. On my end, it really helped empowering the newcomers. It was Puya Parsa who became a lead maintainer of Nux, then Daniel Rowe. And I think crediting people, even if it's small action, a pull request, answering issues, it can be very beneficial to showcase their work, like just a thank you, sometimes just a tweet, adding them in the blog post, showing them that we see their work and we value them. I think it's how you have people that trust you in return and wants to continue helping you. So that's how it worked for us, but it's still very hard to maintain this flow of issues. But,
yeah.
Yeah.
Well, it's a resume builder for these people. Like, oh, I contributed to Svelte. I contributed to Next. Like, here's the stuff that I put in that's in the framework. And they may not be building it, but they can contribute. And we've created this like open source community that we're helping each other learn more, but also get more opportunities. So.
Yeah, I was the person that Rich was talking about, where I got bear hugged to basically be here for 8 years now. I think what was really interesting is that so I came into the Next.js project pretty early, but I was contributing to a bunch of Vercel site at the time projects, and it was more so because there was technical challenge there. Like I could learn something new. I was 19 at the time. I wanted to learn more about JavaScript, and there's one way to do it. And I found that fixing bugs, for some reason, I learned really well doing that. And it's really how we approach this. And for Next.js, it evolves over time as well. Because I think it's this strange thing where well, it's not strange. It's the overall usage goes up. You get more GitHub issues. It's this thing where everyone will find every single bug there is, even if it's that there's a dot or comma somewhere wrong in the docs or things like that. So in the end, what we're doing now is that we're obviously we have a larger team work on it. We're triaging issues every day. There's someone actively working on that. I know that if you're in this room and you've seen issues and they've been open for a long time, we haven't replied yet. I'm very sorry about that. I will say that. It doesn't mean that we haven't seen them. It means that they were either triaged already, but we were keeping them on a list, or they are actually still being worked on, but we can still do better here. I will say that. But then the thing is it will take some time to get through all of those, because it's I don't know, 1,000 open issues. Mm-hmm. And while the number you see keeps going up, actually, if you look at the stats, we're closing as much as there is being opened. But even if that's 10 or 20 or 40 or 50 issues per day more every day being opened than that we close, it just never goes down. It keeps going up over time. And It's a thing that we have because of like large adoption and like a lot of people using it. And also I'll say like we're very thankful for people reporting it to GitHub. If you're reporting it to GitHub and the bot did not close it, you did a super good job because we have a pretty strict bot that will say you need to provide a reproduction because otherwise we will close it. And really the only reason we have that is because we can then correctly triage everything and investigate it really and really fix it for these cases.
But the overarching message is big bear hugs for the community. Yeah.
Yes.
All right, so let's talk about Svelte and NuxLab joining Vercel. So some people were excited, others were curious. So why did you join Vercel? And what has changed behind the scenes with Nuxt and with Svelte?
Oh man, I have so many thoughts. People did have many opinions when I joined Vercel. I'm sure you can relate. So I've been at Vercel for 4 years now, and at first people were like, "Oh no, Vercel's acquired Svelte."
Yeah.
I wish. There was nothing to acquire. It's like an MIT licensed code base. So like I joined as a salaried employee to work on Svelte. People worried that being at a company that exists to make money was going to have a corrupting influence on the roadmap. And I think I can say 4 years in that our track record disproves that. So to the people who thought that it was all going to go terribly wrong, that we were going to start prioritizing Vercel support over being an independent platform agnostic framework, that hasn't panned out for a few reasons. Number one, the 3 people who work at Vercel on the project are a small part of a much larger maintenance team. And if we started to go rogue, then the rest of the team would mutiny, and it would be a short-lived thing. But also, I think what people have come to see is that it's just not in Vercel's interests to exert influence over the roadmap. Like the whole point of the project is that there's no vendor lock-in, that it is designed to be a platform-independent project, and the reason that you would bring your Svelte project to Vercel is for Vercel. And so I think that has panned out pretty well. So I wouldn't say that anything has really changed in terms of the governance and the roadmap. The only thing that has really changed is our ability to ship stuff, because before me being here and latterly Simon and Elliot being on the team, it was like a weekends and evenings project. And any open source project beyond a certain scale, especially when you have beyond a certain number of users, you just can't do it on a part-time basis. Like it needs to be a full-time endeavor. And so being part of the company has made that possible. I mean, I guess it's slightly different for you insofar as there was an acquisition.
On Nux Labs, yes. So Nux Labs was a company, and we had different products around Nux to sustain the open source we've been building. One was Next.UI Pro, which was a premium component libraries on top of Next.UI. The second one was Nux Studio, which was a Git-based CMS on top of your Markdown files. And the last one was Next Hub, which was adding a developer experience layer on top of Cloudflare to deploy your Next applications. Trying to get the Vercel experience on top of Cloudflare, which was not that easy anyway to do. And then I got the opportunity to talk to Guillermo to brainstorm about what it could be to join Vercel. I think it really helped also to have the history of Rich joining Vercel, seeing that the framework was not denatured, like it stayed agnostic. It was very important for us as Next and Nitro to stay agnostic. I think in Vercel interest, it was also important to showcase that it supports multiple frameworks. So at that stage, our strategy aligned. I was excited also by the idea of bringing the team, working full-time all together, and also open sourcing all of our products, because it opens the possibility for the community to access our premium products, making Next.Hub also agnostic, so being able to build full stack application on Cloudflare, but also on Vercel. And that was this thing that was tricky for me, to have something that is locked in. So opening it for the web, I think it made sense. And I can understand people being suspicious, but what I'm telling them is you will see with time, and I'm very confident that Vercel was a great choice.
One of the really cool things with like the Nux Labs acquisition is also that we're talking a lot more now. Like we were talking before as well, but like between our teams as well, there's like quite like there's a lot of overlap. Obviously, like we're building similar tooling. It's not exactly the same. The APIs are not the same. There's all like there's a bundler and there's server-side rendering and like all of these things. And like seeing like even in the last few months, like seeing like Puya like land all these new APIs into Nitro to make Nitro overall better, it's been really cool to see as well.
Yeah, and even the cache system where we've been collaborating. I mean, I was excited to be able to talk with these guys on the same Slack channel. I think this is honestly one of the greatest things.
Yeah, one of the interesting things is that because there's a bunch of people that you'll see from Vercel that are like super super online, always on Twitter, that kind of thing. I'm personally not super like that, but and Rich is not like that as well, and I think Sebastian as well. But things like there's also a lot of like historical, like there's people at Vercel that have shipped like some of the largest like tools in the world at like either like big tech or did it in like open source as well, or other things that you don't know about that really are helping shape this like bringing these tools that were in that always existed at like every single like large company like Meta or Google has, and that could never be brought to open source because like their tooling is like super built towards like their particular stacks. But we're actually now able to build some of these tools as open source for like the frameworks that we're building.
Yeah, I'm super line.
So you had some closed, and then you were able to open it all after joining?
Yes, so which includes all the Next.js Pro components. We are working toward making Next Studio self-hostable, so you will be able to edit your Next content, your Markdown documentation within your website and commit directly to GitHub. So all you need is a hosting that supports server-side rendering and an OAuth GitHub app. And Next.Hub, we are going to release, same as Next Studio at the end of the month, first version capable of running on Vercel.
I got a demo of Next Studio yesterday. It's pretty crazy.
I wish we could do it right now. Okay, so you all have been building frameworks for almost 10 years. A lot has happened in those 10 years. Version 16, version 5, version 4.
Yes.
So what does the next 10 years look like? It's been going on for almost 10. What's the next 10 look like?
More convergence, I think. We were sat in the office yesterday just kind of nerding out over some of the things that we're working on. There are some areas where Svelte and SvelteKit are ahead, and there are a lot of areas where Nuxt is ahead, but like the things that Nuxt has are the things that we want to do next, and the things that we have are the things that Nuxt wants to do next. Cool. And I know that the same is true for Next. I think making these frameworks truly full stack is the overarching trajectory. Like reactivity and rendering, like keeping the DOM up to date is very much a solved problem at this point, but there are a lot of unsolved problems around making storage and auth like straightforward and bulletproof and well integrated into these systems. And these are the things that I know you're pursuing and we're pursuing.
And it overlaps so much that like you can have generic solutions for some things, and that's not to say that we'll ship all of them in the same way and that the APIs are all the same or things like that. But there is a lot of overlap, and IDs and experiences are really helpful here as well. I've noticed. been talking with Daniel on the Nux Labs team like quite a lot. Also just about like open source in general and how we like built this at Vercel. So yeah.
I think we'll see also what the community and users and maybe LLM will ask us to build next. I think the full stack for me has been, I've been waiting for a long time to add full stack feature on Next. I think with the LLM building, we're expecting the LLM to build full stack apps. So trying to define a standard, an opinionated way of building full stack may also reduce the security risk by building it in the open as well and as open source. And yeah, we'll see. We didn't expect to add an MCP server few years ago, and here we have having an MCP server helping developers to build MCP apps. We'll see. It's hard to predict, honestly.
Yeah. How often is this like feeding notes to each other happening? That's fun.
It is. I mean, I wish we could do it more often. Unfortunately, he lives in France.
Well, you're all in the same Slack, so.
We are.
10 years for Next?
10 years for Next. Next 10 years.
Next 10 years for Next.
10 years for Next. Yeah, what is next? No. Yeah, I think like like today at the keynote you saw what our vision is for like what Next.js should look like. Mm-hmm. It's the thing we started 2 years ago. It's getting a really good bundler. It's going to start paying off. Like the thing that I've been talking to a bunch of people, like probably in the audience today, that came up to me and said like Next.js 16 fixed all my problems, which and other problems were slow Next.js dev, to be clear. So the thing here is like we're now at the baseline, right? So this is the baseline of what all the features that we already had are with TurboPack. But now we can start building new tooling. So there's like a better bin analysis tooling coming very soon as well. Like in the next few months, you'll see like a bunch more tooling in this like in that space around like the bundler, because we can now we have knowledge about the end-to-end of like where everything goes. So now that we have this bundler, we can basically we made everything fast. Now we can make it slower again. This sounds crazy, but it means that we can do more work in less time than we did originally, and do more like advanced optimizations. You can do all these things, and that's just for TurboPack. For Next.js itself, like cache components, parts of pre-rendering, and like being able to build these like one page that can do both static and dynamic was always the vision from the like when we started building AppWriter. It just took some time to get there, and it's finally here to try out. So I definitely recommend you to try it out. And then for the next 10 years, it's going to be refinement, getting better DX, like even better DX than you already get. All the error messages should be correct to where like you throw the error if you introduce one. And I'm sure we'll see like something like coding agents and things like that to like bring all these features that are missing there as well.
I would add a small note on, we see the rise of AI browsers now. So I think we are going to see our web frameworks also being able to ship some capabilities for this AI browser to communicate directly with your app. It could be MCP server, it could be a new standard that will come with this AI browser. So I think adapting also to this new browsing experience. Maybe shipping web component directly for the AI browser to use from your website. I don't know. That's exciting.
Yeah, where I see these 3 and 10 years, we're all going to have a chip in our head, and we're going to think, build me a svelte app. And it's just going to build it. That's 10 years from now. OK, so last question. It's not about frameworks. It's not about tech. If you were not in tech, what would you be doing? What would be your job?
Realistically, I'd probably still be in journalism.
Oh, OK, yeah.
I don't know. Most people who work in tech, I think, have some sort of fantasy of doing things with their hands. I really like cooking. Maybe I'd open a cookery school.
All right.
Something like that.
I do like building things with my hand, actually. I like 3D printing a lot, but I guess if tech doesn't exist, 3D printing neither. So I guess probably building houses. I wanted to be an architect when I was young. I mean, building things. So whatever it is.
That's cool, yeah.
Cool. For me, it's completely different. I think I would probably end up working in my parents have a gardening center in the Netherlands, and I know nothing about plants. Don't come to me with plants questions, but I would probably be working for them, like most likely in their business. It's an interesting business. They actually do e-commerce as well, which is they bring plants to you using it's a whole logistical thing. So you can do whatever. You don't have to work. You don't even have to touch plants to work in a gardening center. How is that? Yeah.
So we have a gardener, we have a journalist, and we have an architect. I love it. All right, well, that's it from me. Thank you so much to all three of you.
Thank
Give
you.
it up. All right, we are at the end of the day. So we've had a great time together. So this is a dream for me. I've been in the Next.js community for many years. I've spoken on this stage many times, and now I get to close it out. So this is very unreal for me. I'm very grateful to be here, and I'm so grateful to be able to have met all of you today. So let's recap the day. We kicked this morning off with Guillermo, Sam, and Jimmy, and they had a wonderful keynote. There's been nonstop energy and demos and a lot of good learnings and takeaways. We saw what's next with Next.js. We talked about the future of coding and AI, and we got a glimpse of how teams are building faster than ever. So some of the sessions included stuff like Lydia, who was just on stage. She showed us about Bun. Reese's session talked about dynamic pages. Ryan's talk was about AI is not just a buzzword, but something we can use every day. So we're so grateful to all of the speakers. The talks were world-class and reminded us how much creativity lives in this community. And thank you to all of our sponsors. It's just a great group of companies out there. So if you've got tickets for Ship AI, that is happening tomorrow, right here, same time tomorrow. It's going to be another amazing day where we're going to talk about AI-powered experiences. And for tonight, we're not done yet. We have happy hour, which runs until 8 p.m. immediately following this. Go grab a drink, find someone you've met today, or say hi to folks that you've been following online. This is the perfect time to connect. So the connections I've made over the years at Next.js Conf are the reason I'm here today. So go make that friend. Tell them Cap told me to introduce myself. Oh, I wasn't clicking. There. Those are the things. So on behalf of everyone at Vercel and the Next.js team, thank you. Thank you for showing up, for experimenting, for pushing the web forward, and for being here. It really means a lot to us. We can't wait to see what you all build next. Y'all are amazing. Now, I'm from Hawaii. Being from Hawaii, I have to do my Hawaiian word of the day, or today it's a little phrase. So many of you know this, but in Hawaiian, mahalo is thank you. But if you want to express great gratitude and like deep thanks, you say mahalo nui loa. So mahalo nui loa, everyone. I'll see you at happy hour. Thank you.